Hello.
So far we discussed the estimation of OLS equal. And the technique of estimation is OLS. Why OLS? Because it gives best linear unbiased efficient estimator. So best linear unbiased means if you repeat that process in a different sample, you will get a different values of beta 1. And if you take the average of the sampling distribution of beta 1, you will get it is equal to the population parameter, and that's why it is known as unbiased. Best means within the class of unbiased and linear estimator, the variance of this distribution is minimum. And since the variance is minimum, therefore it is efficient. And that's why we want that the estimator should be best linear unbiased. And the OLS method gives all. But this requires certain assumptions about the distribution of error term. We develop a model y is equal to beta 0 plus beta 1x plus beta 2x plus beta 3x plus u. Now, what is the distribution of this u? We are assuming certain assumptions about the distribution of u. And because we don't have x, we have the data, y, we have the data, and on the basis of data, we are estimating, but we don't have anything related to error term. So all we are assuming that this model will generate u, which will have zero mean, constant variance, interdependence of the two error term, independency of the x values and u values. These are all known as classical linear regression model. Assumptions of classical linear regression model. And if you have these assumptions, then OLS will definitely give best linear unbiased one. But suppose our model formation is, because of some issue, we are not able to get the standard format of the error term. Means that error term doesn't follow the assumptions of classical linear regression model, then what will be the implication on OLS? Whether still OLS will give blue or not. And if it is not giving blue, then how to test whether it is following the assumptions of OLS not, and then what are the remedial measures, how to test, all that we have to discuss. So today we will be taking one by one assumptions, and we will drop that assumption, and we will see what are the consequences. It requires a lot of sophisticated mathematics, so I am not using that mathematics. So far we discussed without derivation the conceptual part of the econometric estimation. So today also I will take the conceptual part, and then through example we will try to see what are the consequences that if we ignore these assumptions and still estimate OLS, what will be the issues related to estimation that we will try to cover. So first assumption is that expected value of u is equal to 0. And theoretically we can say mean for the disturbance means if it is not 0, expected value of u is not 0. In that example, I generated fixed values of income, different values of the consumption, and because of different values of consumption, we have the error. And in all that, what we are assuming that there will be some plus error, some minus error, like in the deviation, and sum of the deviation is equal to 0. So similarly, we are assuming that the sum of the error term is equal to 0. Now, if it is not 0, what will be the consequences? So definition, the disturbance have a minimum mean other than 0. That is the first. Means we are dropping the first assumption. We are replacing the first assumption. Note that this refers to the true error term. Hence, the estimated error term, the residual have mean of 0. Estimated value will definitely be 0 because the concept of y minus y cap, so that the estimated value will be 0. But theoretically, if the residual is of not 0, what will be the implication of using OLS. What we are interested that even if expected value of u is not equal to 0 and we are using OLS, what will be the implication? So cases, non-zero mean result from some form of specification error. Why there can be a non-zero u? Because of some specification problem. And this specification problem may be because of the two reasons. One, because of the omitted variable. Some variable is affecting the dependent variable, but somehow because of our ignorance, we are not using that variable in the regression. Take a simple case. You must be knowing what is the shape of the average cost curve. Average cost curve, U-shaped curve, clear? And U-shaped curve, and what is the x-axis? It is the output, and y-axis, it is the average cost. So we have a combination, and suppose instead of U-shape, we are using linear relations. U-shape means the average cost is equal to a plus bx plus cx square. Quadratic equation, then it is a U-shape. Instead of quadratic equation, we are using linear one. U शेप में लीनियर रिलेशन आप करेंगे तो क्या हो जाएगा, स्ट्रेट लाइन आ जाएगी. यू शेप कॉस्ट कर्व है, इसका मतलब क्या चीजें आ रही है, तीन चीजें इसमें इंक्लूडेड. देयर आर थ्री थिंग्स: इंक्रीजिंग रिटर्न्स टू factor, diminishing returns to factor, and constant returns to factor. Now, if you ignore square value of the x and just regress y on the x, it will be a linear relationship. Linear relationship, and you will find that the relation is positive, means as x increases, average cost increases. But in reality, as x increases, your average cost is bound to decrease up to certain point. So this is known as misspecification of the functional form. Instead of quadratic equation, if we are using linear equation for the estimation, there will be a problem of specification of the functional form. And since there is a problem of specification of the functional form, so the error term will not be zero. Mean of the error is not zero. तो पहला कारण क्या होगा? Omitted variable. The other reason is functional form. It is quadratic equation, but we are using linear equation. Suppose you want to estimate the cost function. What is the nature of the cost function? It is a cubic function. Why we have a cubic cost function? Because of the three returns: increasing, diminishing, and constant, and we want to incorporate all. Now, instead of cubic function, suppose you use linear function. What is linear function? Cost is a function of output. That will create a problem of misspecification, and in this case, expected value of u will not be zero. So, first assumption, if we are dropping that the expected value of u is not equal to zero, the interpretation of intercept will be wrong. And not only the intercept will be wrong, but the slope coefficient will also be wrong. So I am taking two cases here. Expected value of ui is equal to mu, not equal to 0. And second case, I am taking expected value of ui equal to mu I, not equal to 0. Now, what is the difference between these two cases? What is the difference between these two cases? First case, I am assuming that expected value of u 0 होना चाहिए, पर ये 0 नहीं है. क्या है? म्यू के बराबर है. इसका मतलब 0 की बजाय 5 है, 0 की बजाय 8 है, 0 की बजाय 10 है. क्लियर? दूसरे वाले केस में क्या? एक्सपेक्टेड वैल्यू ऑफ यू आई इज इक्वल टू म्यू आई, नॉट इक्वल टू 0. क्या अंतर है दोनों में? नहीं, हेट्रो और होमो तो आया ही नहीं अभी तक. नहीं, यहाँ क्या केस हो रहा है? म्यू आई है. म्यू आई का मतलब क्या है? इफ इट इज u1, द वैल्यू विल बी mu1. इफ इट इज u2, वैल्यू विल बी mu2. If it is u3, value will be mu3. इसका मतलब जीरो नहीं है पर कांस्टेंट भी नहीं है। पहले वाले केस में क्या है, फॉर एवरी वैल्यू ऑफ यू इट इज कांस्टेंट, every time it is not 0.555, so if it is 5 you will be able to easily interpret it. But for every error term, if it is the value of the expected value is changing, it will be uh, difficult to measure it. So these are the two cases we are discussing. First case, expected value of u is not equal to 0 but equal to mu. What does it mean? Expected value of y is our dependent variable with respect to what? X. Means in regression analysis we are assuming x is a fixed variable, and for a given value of x we want to estimate the value of y. So this is known as expected value of y for given value of x is equal to alpha plus beta 1 x प्लस यू आई। और अब इस यू आई की बजाय हम क्या रखेंगे, यू आई विल बी इक्वल टू व्हाट, अल्फा टाइम्स म्यू, अल्फा प्लस म्यू। म्यू इज द कांस्टेंट, समथिंग वी आर एडिंग। तो इसका मतलब क्या है कि देखिए अगर आप ये वैल्यू सब्स्टिट्यूट करेंगे तो फाइनली इट विल बिकम वाई आई इज इक्वल टू अल्फा स्टार प्लस बीटा एक्स आई प्लस यू आई स्टार। Expected value of u is not 0 but expected value of ui star is equal to 0. एडजस्ट कर लिया हमने, u माइनस म्यू कर दिया है, अल्फा माइनस म्यू। इसका मतलब ये हुआ कि अगर फर्स्ट केस में एक्सपेक्टेड वैल्यू ऑफ ui इज नॉट इक्वल टू 0 तो क्या कॉन्सिक्वेंसेज होगा, आपका अल्फा और अल्फा स्टार अलग अलग। तो अल्फा, what we are interested, we are really interested in alpha, not in the alpha star. But we know that if somehow we know the value of mu, then we can work out alpha star just substituting the value of mu. क्या आ गया भैया, डिक्लाइन या अप्रूव?
नहीं रखा था, नहीं है इसमें,
नहीं। The only point which I want to say that the actual value of intercept will be different than what we are estimating. We will be estimating alpha star, but our real value is alpha. And through alpha star, we can work out alpha if you know the value of mu. जीरो नहीं है और कितना है ये अगर पता लग जाएगा तो उस अल्फा स्टार में से उस पर्टिकुलर वैल्यू को माइनस करके हम अल्फा निकाल लेंगे। इसका मतलब अगर हम फर्स्ट अजम्पशन को रिलैक्स करते हैं तो इट विल नॉट अफेक्ट द स्लोप कोएफिशिएंट, इट विल अफेक्ट ओनली द इंटरसेप्ट। ठीक है, और ये जो अजम्पशन क्यों रिलैक्स हो रहा है, द एक्सपेक्टेड वैल्यू ऑफ इज नॉट इक्वल टू 0 बिकॉज ऑफ द टू रीजन। वन इज omitted variable. We are assuming that y is a function of x1, x2, x3, three variable, but somehow we are not able to collect the information of x3 third variable, so we are regressing y on only two variables, and because of that there will be a specification bias, and because of this specification bias our intercept will be wrong. This is one. But if you assume the second case where expected value of ui is equal to mu I, and for every u the value of the average is different, it will then create a problem and we will not be able to estimate even the correct intercept and correct slope coefficient. So this is one. Like this one, the second case when expected value of ui is equal to mu I, and mu I means changing for every observation, then it will be difficult to work out because what we should minus 5, 6, 7, 8, and for every observation it is changing, so it will be difficult. In fact, there are n intercepts. Xi, mu I means for every observation, there is one mu, u1 giving mu1, u2 is giving mu2, u3 is giving mu3. So we will, how much intercept we will get? N intercept. So this is a, so unless we have repeated observation like in panel data, or we have some prior information on this alpha star, we cannot estimate this model. This is one. Now, the second assumption is that x should be fixed variable. What are the x? X is our independent variable. They are fixed. They are not random variable. They are not random variable. Y is a random variable. Error is a random variable. But x explanatory variables are not the random variables. Suppose they are the random variable. Nature of state. Random variable means stochastic variable. The second OLS assumption that X are non-stochastic fixed हैं. जैसे हमने income के केस में लिया 80, 100, 120, they are the fixed income, और उसके respect में we have selected a sample whose income is same but the consumption is different. So suppose your X is also random variable, what will be the contingent? What does this mean? Is this a practical assumption? Because what we are getting, we are estimating the value of dependent variable for a given value of x. So we are assuming that x is a fixed variable. If x are stochastic, then we must specify how the x and u are. Because u is also random, x is also random, then what is the nature of relationship between x and u that we have to predict? Two possible cases, x and u are independent. X is a stochastic variable, U is also a stochastic variable, but what we are assuming, they are independent. And simply correlated with the disturbance term means X and U are not independent. What will be the consequences? Yes. So if they are the independent one, there will be no problem. Your estimation will be still blue, and the OLS will give you best linear unbiased estimator. Clear? But if they are correlated, means then X is affecting Y, error is also affecting Y, and both X and Y jointly affecting it. If X is a stochastic variable, then both the distribution X and U distribution should be independent. That is our assumption. And if they are interrelated, then they will cause bias in the estimation. तो पहली बात जो है कि अगर आपका एक्सपेक्टेड वैल्यू ऑफ यू इज नॉट इक्वल टू 0 और एक्स स्टोचेस्टिक है, तो क्या इश्यू आएगा कि जो एस्टिमेशन है इंटरसेप्ट का वो बायस बन जाएगा, और ये जो आपका वैल्यू आ रही है that will not be, we will not be able to estimate अगर ui is equal to mu I. The second assumption we are assuming is the distribution of u is normally distributed. Though it is not, the normal distribution doesn't require anything related to blue, best linear unbiased, nothing. But normality assumptions require when we want to use the estimate for testing of hypothesis and estimation of the parameter, interval estimation. Now the problem is that you have the standard error, you are working out the t value or the z value, then we are comparing on the basis that that particular distribution is normal distribution. So this is important. If it is not normal, we will not be able to conduct the test of hypothesis. A collection of truly stochastic disturbances should have a normal distribution. So normally, if you are selecting a random variable will definitely have a normal distribution. The central limit theorem states that as the number of random variables increases, some of their distributions tends to be normal distribution. So large number of observations हैं, large number of variables हैं, and if your U is normally distribution, then definitely it will have a normal distribution and there will be no problem. Non-normality generally caused by misspecification, and misspecification because of the wrong functional form or because of some omitted variable. Usually an omitted variable causes the misspecification, and if there is a misspecification, then there is a chance that U is not normally distributed. इसका मतलब पूरा का पूरा format of the model is very important, and we should form the model on the basis of theoretical background. Clear? Second, can also result from outlier in data. कुछ डेटा इतने ज्यादा बड़े हैं, एकदम 100 से बाद फिर सीधा x की वैल्यू 1000 आ जाए, तो एकदम एक्सट्रीम वैल्यू मे बी लोअर वैल्यू और मे बी हायर वैल्यू, that can also cause misspecification in that. And wrong functional form, it is really a cubic function, but we are using quadratic equation, then that can cause misspecification. And because of misspecification, there is a possibility that U is not normally distributed. How to test it? Draw a histogram of the error term. X-axis is the error term, and y-axis we can take the density, or you can take the frequency. So different values of E, what is the frequency, and to draw a diagram, and if the diagram is like this histogram, you can say that U is normally distributed. So these are the two curves. Now, there is one more test to test whether you are really, your distribution is normally or not. And the name of the test is Jarque-Bera test. In Jarque-Bera test, we are working out, or we are calculating JB. And what is JB is equal to n s squared divided by 6 plus k minus 3 squared divided by 24. K minus 3 whole square divided by 24. 6 and 24, they are the fixed. N is the size of the sample. S is the coefficient of skewness. Carl Pearson coefficient of skewness, you must have worked out in the statistics. There is a standard deviation and then skewness. Whether your distribution is skewed or unskewed. So if it is a symmetrical distribution, we will say it is a skewed distribution. And in the skewed distribution, S will be equal to 0. And even K is kurtosis. So in a symmetrical distribution, ये सब अगर आप करेंगे is equal
I'm not audible to.
So it is like a chi-square distribution. And in chi-square, JB we will compare with the chi-square at different level of significance and 2 degrees of freedom. If our value is greater than table value of chi-square, we will reject null hypothesis. Otherwise, we will accept it. So this is another test by which we can judge whether U is normally distributed or not. So S is a coefficient of skewness, K is the kurtosis, 3, 24, 6, they are fixed one. So, and if it is a normal distribution or symmetric distribution, S will be 0, K will be 0. So you can say that the value of JB will be 0. So if value of JB is closer to 0, you can very well assume that your U is normally distributed. And if it is different, then compare with the chi-square. Comparing with the chi-square means there is a standard table of chi-square, and what will be the degrees of freedom? 2 will be the degrees of freedom. If our value of JB is greater than the table value of chi-square, reject null hypothesis. Means U is not normally distributed. So first assumption, what we are assuming that U is जी ये मतलब स्टेटा is the software. So if you want to calculate this particular value, then there is a command sk test. यहाँ for JB. So directly Stata will give you the value of JB. You have not to bother about the calculation of this SK test. Just you have to click the command on. Now the assumption, classical linear regression model assumption, first assumption is U is normally distributed with zero mean. And second is variance is a constant. And if variance of the disturbance term is constant, then that terminology is known as homoscedasticity. Now suppose the variance is not constant, then the problem is known as heteroscedasticity. The problem is known as heteroscedasticity, and we want to see what is the nature of heteroscedasticity, what are the consequences of heteroscedasticity, how to detect the heteroscedasticity, and then what are the remedial measures. These are the 4 issues everywhere we will take whenever we drop 1 or 2 assumptions. Pehla, nature means whether it is a positive, negative, what is the relationship between all, what is the nature of heteroscedasticity. Then consequence, what is the meaning of the consequences? Even if your model is heteroscedastic, and you are using OLS method, परवाह नहीं कर रहे हैं उसकी और आपने रन कर दिया OLS, you will get the beta 0, beta 1, क्योंकि when you are fitting data that this is a dependent variable, these are independent variable, रन करोगे तो beta 0 भी मिलेगा, beta 1 मिलेगा, standard error मिलेगा. The issue is related to interpretation of these results. So what will be the implication if you are using OLS even to the heteroscedastic model? That is the meaning of the consequences. And suppose you have established that there is a heteroscedasticity, then how to detect it? What is the degree? And the model is heteroscedastic, then what is the remedial measure? Whether there is a need to improve OLS or we can use still OLS. These 4 things we will be discussing here. Okay, what we are assuming that every X is generating a distribution of U. Every X is generating a distribution of U, and what we are assuming that the mean of the error is 0. This is first. And second, what we are assuming, the spread is similar, whether it is the lower value of X or whether it is the higher value of X. Clear? And if the spread is same, uniform, then we will say it is a homoscedastic model. And if it is a homoscedastic model, we can use OLS very well. There is no consequences of that. But suppose you have a model in which it is difficult to assume the uniformity of the spread of the error. For example, in cross-section data, when you are taking consumption function as a function of income. Now tell me the spread of the consumption in the lower income group and the spread of consumption in the higher income will be same or different. Spread of the consumption in the low income group and spread of the consumption in the high income group. कहाँ ज्यादा होगा spread? लो इनकम में तो कोई पॉसिबिलिटी नहीं है, इतनी कम इनकम है कि बेचारा फूड पे खर्च करेगा हर व्यक्ति, गरीब व्यक्तियों के कंजम्पशन पैटर्न में कोई डिफरेंस नहीं. लेकिन रिचर इनकम ग्रुप में there is a huge varieties of the consumption and therefore there is a huge variation. इसका मतलब the variance is not constant if we are taking income consumption relationship, and that problem is treated as heteroscedastic because every X is generating a U and that U has a different spread. It's not uniform spread. तो ये देखिए मैंने डायग्राम एक ग्राफ बनाया है. तो क्या दिख रहा है ग्राफ में कि आप as the value of X increases, the spread of the error term increases. Here the spread is low. All is concentrated around the estimated line. Here there is a high spread. You can say that the variance is increasing with the value of X. Next वाले पैटर्न में वेरिएंस इज सिमिलर. देखिए आप एक जैसा वेरिएंस लग रहा है चाहे लो वैल्यू हो चाहे हाई वैल्यू हो. Again the variance is increasing. Two separate group. एक estimation में बहुत concentration है. High income के लिए there is a huge spread. Means the variance is not constant. Heterogeneity means that the relationship between the dependent variable and independent variable differ within the sample. एक sample के अंदर अलग है, दूसरे sample के लिए अलग है. Income is less important as an explanatory variable food expenditure of high income family. So if you want to know the consumption expenditure for high income, you can say that income is not very important variable in explaining the food expenditure. Heterogeneity is likely to be more common in cross-section data rather than time series data. ये याद रखिए कि whenever you are using cross-section data, there is a possibility of heterogeneity. ये जो distribution बनाया means every value of X is generating a distribution like this. This is a normal distribution and you can say that the spread of all U is more or less same. तो ये पहला डायग्राम क्या एक्सप्लेन कर रहा है? होमोसेडेस्टिक मॉडल. और दूसरा डायग्राम देखिए कि बहुत ही पीक है, उसके बाद स्प्रेड बढ़ रहा है, फिर स्प्रेड बढ़ रहा है. द वैल्यू ऑफ एक्स इंक्रीजेस, द वेरिएंस ऑफ द डिस्टर्बेंस इज इंक्रीजिंग. तो सेकंड मॉडल क्या एक्सप्लेन कर रहा है? हेटेरोसेडेस्टिक मॉडल. फर्स्ट एग्जांपल इज एक्सप्लेनिंग होमोसेडेस्टिक मॉडल. Heterosedacity is a systematic pattern in the error. Heterosedacity is when एक sample, दूसरा sample, fifth sample. This means dispersion of the dependent variable around regression line is not constant. Spread across the estimated line is not constant. Then all. Recall that the sigma u squared measures the dispersion of the dependent variable. Why do we require sigma u square? किसकी कैलकुलेशन में सिग्मा यू स्क्वायर चाहिए? When we work out the standard error of beta 0 and beta 1. And what we are assuming, since sigma u square is constant, so we are taking one value and then we are estimating, and sigma u square is equal to summation e square divided by n minus k. That is the formula for the estimation of sigma u square. Now tell me, if sigma u square is not constant, for u1 it is different value, for u2 it is a different value, for u3 it will be different value, then we will be in trouble estimating the variance of the beta 0 and beta 1 because it is not constant. Which value will take? Means for every error term we will take a different value, so we will not be able to estimate. और अगर हेटेरोसेडेस्टिक है इसका मतलब it will be difficult to estimate the standard error. अगर standard error नहीं निकालेगा तो क्या होगा? तो statisticity one is not integration model is not heteroscedastic, but because we are ignoring something, misspecification, that is causing the error, and that we are showing it impure. This is all because the population regression model is good, but sample information somehow they are taking wrong method of relation. What is the reason for the heteroscedasticity? These are the reasons following the error learning model. Effect, data collection, the presence of specification error, and structural change in the data. Maybe any reason. So scale effect, what is the scale effect? Somehow the values, कुछ values तो 10 है, कुछ value 10,000 आ गया है. So scale effect, or if you want to remove the scale effect, what you can do? You can take the log value. X 10 log, log 2. So you can reduce the scale by taking the log. Data collection, if there is an error in the data collection, then that can also cause the heteroscedasticity. Presence of outlier extreme value आ जाए, specification error because of misspecification, skewness of the regressor. Regressor means the dependent variable, and if there is a skewness in that, then it can cause a heteroscedasticity. Structural change in data, for example, suppose you want to take the estimation of GDP of our country, what is the trend of the GDP? Now there is a structural change after 91. Now, as I said earlier, the OLS estimates are still unbiased and consistent. So even if there is a problem of heteroscedasticity, unbiased will not affect, means your OLS using in the heteroscedastic model will still be unbiased. It will be still be consistent. Consistency means if you increase the size of the sample, the value approaches to population. To take it out, and therefore estimation of error term will be impossible, difficult. The variance reduces the sigma square x transpose x inverse if omega is identical. Omega means that the term is using omega. Under hetero, the variance and standard will be based on long expression. The standard T and F will no long. क्या हो रहा है? मेरी आवाज ही तेज है, पहुंच जाती होगी. अब आ जाएगी आवाज? So estimator is still unbiased under heterostatic, but no longer best one, because variance is not minimum, therefore it is not best one, and therefore we have to search for some other technique, or we have to modify the. Now, how to detect the heterostaticity? What is the way that you have the variable y x2 x3 about heterostaticity and use OLS and get the calculation? And on the basis of the calculation, calculate the value of E. And on the basis of E, we will judge whether there is city or not. So informal, and in informal, what we are doing, just we are plotting the data on the graph, and then there are formal tests, and on the basis of formal tests, we can also detect the heterostaticity. And in the Stata or in the SPSS, there is a direct command for the heterostaticity will tell you whether your model is heterostatic or not. So first of all, develop a scatter diagram of the residuals. As I said, regress y on the x, calculate the error term, and then plot that error term on the graph and see what is the nature. So if it is a completely unsystematic pattern, then forget that there is no question of heterostatic. If there is a specific pattern like third and fourth, then there is a pure possibility of heterostatic. So this is known as informal method. Part test is there, and in part test, what we are doing, part test is in two-step procedure. We divide the sample into two parts. Middle की observation को drop कर लेते हैं. First sample में we regress y or x, and then we calculate the value of b1. And in second, we again regress y or b, and if b is stable or not, then on the basis of that, you can judge whether there is a heterostaticity or not. Similarly, we have this test. I'm not going in detail of this. आप चाहे तो उसको देख लीजिएगा. ये इसके formulas हैं. Sigma 1 square upon sigma 2 square, two different samples, and then the residual sum of squares, and then on the basis of T value and F value, we can judge whether this is a heterostatic model or not. Now the next issue is, suppose there is a heterostaticity, what to do? How to improve the model? So one observation is that if the heterostaticity is not very serious, only some degree of the spread is different, don't bother. Go for the calculation, you will get and you can test. Otherwise, you have to modify the method, and in modification, we have generalized list square method, weighted list square method, visible list square method, and heterostatic consistency estimation method. These are the, in the software, they are all given. Now, you can justify that one method, and here we are improving it. We are improving, that's why it is generalized list square method, weighted list square method, visible list square method, or heterostatic consistent estimation method. Clear? Now, the basic reason for the heterostaticity is that the variance is link with X value. X is what? Independent variable. So if your variance is in lower value of variance, higher value of X, the variance is a function of X. Variance is a X. And if you know that the variance is a function of X, then you can modify your regression line. How you can modify? Y is equal to beta 0 plus beta 1 X plus Ui. And this Ui, the variance is not constant. Divide throughout by Xi. So Yi divide by Xi, divide by Xi will cancel. So your slope coefficient will become intercept, and your intercept will become the coefficient of 1 upon X. Modify the regression line when there is a heteroscedasticity, assuming that X, the variance is a function of X. Now, what is the nature of relationship? That will decide whether we divide by X or whether we divide by X square or 1 by X. That is known as. So what we are doing, instead of simple OLS, we are using generalized least square method or weighted least square method. Means we are regressing not Y on X, we are regressing Y upon X on 1 upon X. That is the reason. So I am coming to this part. This is again in the matrix form, so we have not covered the matrix part. The weighted least square method. Now, example, the same I am taking household income. Household that earn little must spend it all on necessities for low income group when income is low. There is little variance in the spending. That's why we have Angel's curve where the low income group is spending maximum part on the food. And as you grow, the expenditure on food reduces. Household that earns a greater deal can either spend it all or buy just essential and save the rest. More error, variance as income increases. So variance is not gone. So in the following simple saving function, income is suspected hetero-variable. So this is the saving is a function of beta 0 plus beta income. 0 plus beta income plus UI. Thus, it could be used to be constant variance. Now, to make constant what we are doing, because the first model, this model is what? This model is that UI is a heteroscedastic model. Now, we have to remove the heteroscedasticity. We are regressing this saving on income. What we are doing, we are dividing through income. Say by means we have 100 household, every household saving is there, income is there. What we are working out, average saving divided by income, and beta 0 divided by income plus beta 1 income will cancel out, only beta 1 will be there. So there are two variables, beta 2 and interest rate. Saving is a function to income and interest rate. So what we are assuming that these are the two variables, and because of that there is a heteroscedasticity in the model. So what we are doing, saving divided by income equal to beta 0 divided by income plus beta 1 plus beta 2 multiplied by interest rate divided by income, and plus error term divided by income. Error term divided by income. Now our error is, earlier it was heteroscedastic. So if you reduce that by scale, because we know that the variance is a constant function of income. So if you divide it by income, then the ratio will have a constant variance. So here in the new model, this new error is free from the heteroscedasticity. So instead of regressing 7 on income and rate of interest, what we are doing? We are regressing average saving. In saving divided by income is nothing but average saving on inverse of the income. Beta 0 upon income means 1 upon income. Plus beta 1 plus beta 2 interest rate divided by income. So if you change the scale, your new model will be heteroscedastic and you can easily interpret the result. But the only difference is now beta 0 is the slope coefficient and beta 1 the intercept. And in the original model, beta 1 is the slope coefficient of the income. So suppose you are interested in the marginal propensity to save, then beta 1, the intercept of the second line will be the marginal propensity to save. इन दोनों के coefficient के interpretation में we have to be careful. और ये beta 0 क्या है हमारा? ओरिजिनल इक्वेशन में इंटरसेप्ट है और जो नई रिवाइज मॉडल है उसमें दैट इज द स्लोप कोएफिशिएंट ऑफ द इनवर्स ऑफ द इनकम. तो जो हमारे पास वेरिएबल्स हैं डिस्ट्रीब्यूशन फैमिली का कहता है एक तरफ इनकम के डेटा, एक तरफ हमारे पास सेविंग के डेटा है, दूसरी तरफ इनकम के डेटा है और तीसरा वेरिएबल हमारे पास इंटरेस्ट रेट है. अगर सेविंग को इन दो वेरिएबल पे आप रिग्रेस करोगे तो हेट्रोसेडेस्टिक मॉडल है और इसलिए एफिशिएंट नहीं है. क्यों एफिशिएंट? अनबायस्ड तो है और एफिशिएंट नहीं है क्योंकि वेरिएंस इज नॉट मिनिमम. तो इन ऑर्डर टू मेक एफिशिएंट वन व्हाट वी डू, वी हैव टू चेंज दिस वेरिएबल. तो सेविंग की बजाय हम क्या लिखेंगे? सेविंग अपॉन इनकम. एवरेज सेविंग निकालेंगे और एवरेज सेविंग विल बिकम द dependent variable of the new model. तो सेविंग डिवाइडेड बाय इनकम फॉर ऑल हाउस होल्ड. फिर दूसरा हमारे पास इनकम है, उस इनकम का इनवर्स निकालेंगे 1 अपॉन इनकम. और तीसरा इंटरेस्ट रेट डिवाइडेड बाय इनकम. तो वी आर चेंजिंग द इंटायर डिपेंडेंट और इंडिपेंडेंट वेरिएबल in order to get the efficient value of beta 0, beta 1 and beta 2. So average saving as a function of inverse of the income and interest rate divided by income. So this way if you do, you will be able to remove the heteroscedasticity. So here what we have assumed that x, the sigma u square is a function of x and therefore we have divided by x. But suppose it is not x, something different, sigma u square is equal to x square or k times x. In that case, we have to use weighted sum. So y, your income is there, saving is there, interest rate is there. To give some weightage, the error way to work out the variance of the new error term, it will be so software. You will always find all these adjustment in the software. You know to the calculation of this one. The only thing, so in the heteroscedastic model, this is a problem related to cross section. This is one thing which is very important. If the time is data, then you have no bother about the heteroscedastic. Now, heteroscedastic is not a very serious issue. It's not a very serious issue. So, because still it is giving unbiased, and if the degree is not much, you can get a efficient estimate. And the simplest way is if you assume that the size of the income is generating different type of variance, then what you have to do? You have to just change the variable, divide throughout by income, as we did in the saving function. So what we are doing, we are not regressing actual value, but we are regressing the ratio variable. Ratio with respect to income or ratio with respect to the size of the family or any other thing. So that is the way you can work out this. Now the next is linear regression model. चाय ओके सर आए तो चाय आनी चाहिए ना. Yes. So now after tea break, we are ready for multicollinearity. The issue of the consequences of the OLS assumption, the point which I want to emphasize is that simply regression is not econometrics. Regressing y on x, 2x, 3x, 4 is not econometrics. And 90% of the students are doing regression without knowing the implication of their results. They are doing econometrics. Why? Because easily it is available on the software. Data feed karo, calculation ho jayega. So through this, the relaxing assumption, just I want to highlight that you should be very careful when you are selecting the model. Think that there are issues and just the interpretation of result is not enough. Formation of model is much more important than the estimation of the model. Otherwise, derivation and all, they are a very difficult process. You have to go through the learning process, and it is really difficult in covering all these assumptions into one lecture or two lectures. So just I am motivating, try to understand the econometrics, and if you are motivated, then you have a good teacher. So they will explain what and how to clear the exam, how to use the econometrics and so on. So we have discussed two things. One, the assumption of normality and with zero mean, and second is the constant variance. And if the variance is not constant, even it will be difficult to estimate the variance of the error term. And if you are not able to estimate the variance, it will be difficult for testing of hypothesis and so on. The next one is multicollinearity. Now, tell me, multicollinearity is a problem of simple regression model or multiple regression model? In simple, there is only one independent variable, so there is no question between the correlation of the two independent variables. But in multiple regression model, when you have many independent variables, and if somehow regression model. If you take income and asset, again the possibility there. So means all economic variables, they move in a certain direction, tendency, and therefore there is a possibility of multicollinearity. So multicollinearity is most of the time will be there in the multiple regression model. Multicollinear originally it means the existence of perfect or exact linear relation among some or all explanatory variable of the regression model. एक बात ये याद रखिए multicollinearity में कि only we are concerned with linear relation between x2 and x3. If it is non-linear, it will not cause multicollinearity. So this is, and then there are two. Exact correlation means perfect R equal to 1, and if there is a high correlation, then there is a different case. So we are perfect or exact linear relationship among some or all explanatory variable of the regression model, then that is known as multicollinearity. For the k variable regression involve explanatory variable x1, x2, x3 up to kn, and suppose this is the exact relation is said to exist the following conditions equal to 0 lambda times x1, x2, मतलब completely exact correlation है. You can say that x2 will be sometimes of x3, x3 will be some multiple of x2 and so on. Where lambda 1 such that इनके बीच में अगर आप correlation निकालेंगे तो you will find that there is a perfect correlation between x1 and x2. And therefore you can say there is a possibility. अब जैसे ये x2 is equal to minus lambda 1 upon lambda 2 this, and lambda is not equal to 0, you can write the equation like this, and then this all is an example of the high degree of multicollinearity. So for example, when we measure the cubic function, y is equal to x1 square x1 cube, three independent variable, one dependent variable, and variable is only two, y and x. For example, in the cost function, cost is a function of output, and output is what? X1. Here we cannot regress y on x1. We have to regress y on x1 square of x1 and cube of x1. So x1 square, x1 cube, three independent variables. And definitely you can say that there is a very high degree of relationship between x1 and x1 square, perfect even if you take the quadratic relationship, x1 and x cube. एक ही वेरिएबल है उसका क्यूब है तो रिलेशन दिखेगा, but it will not cause multicollinearity because the relation is not linear. In multicollinearity, we are concerned only linear correlation, not the non-linear correlation. Now, if you take the x2 and x3, 10, 50 means 5 times the x1, 15, 75, again 5 times, 18, 90, 5 times, 24, 120, 5, 6, 5 times, 30, 150, 5 times. So what will be the correlation between x2 and x3? Perfect one correlation, because x3 is nothing but 5 times of x2. So if you have this type of relationship, your correlation will be perfect. And if you include x2 and x3 in the regression analysis, your estimation method will break down. Your estimation method will break down. दोनों correlation perfect हैं, तो आपका बीटा 0, बीटा 1 निकल ही नहीं पाएगा, क्योंकि दोनों के बीच में perfect correlation. But if you consider x3 as 52, 75, 97, 129, then it is not an exact relationship. Therefore, the correlation between x2 and x3 star will be high, but not 1. And in that case, you use these two variables in the regression model, you will be able to estimate. The third column shows that here is no longer perfect collinearity between x2 and x3 star. However, the two variables are highly correlated because calculation will show that the coefficient of correlation between this is 0.999, almost 1. तो इस तरह का अगर आए तो यू कैन से परफेक्ट मल्टीकोलिनियरिटी. ये पहले वाला केस नॉट परफेक्ट हाई कोलिनियरिटी, सेकंड वाला केस इज परफेक्ट कोलिनियरिटी. Graphical explanation, x1 and x2 is affecting y, इंडिपेंडेंट कोई कोरिलेशन नहीं है x1 और x2 के बीच में, यू कैन से इंडिपेंडेंट है एंड देयर इज नो क्वेश्चन ऑफ मल्टीपोलियरिटी. x1 and x2, there is some combination of these two jointly, and therefore you can say small correlation. x1 and x2 overlapping, and both are affecting y. So x1 is affecting y, x2 is also affecting y, and then jointly x1 and x2 is affecting y. So you can say there is some degree of correlation between x1 and x2. In third one, you can say x1 and x2, they are completely overlapping, so you can say high degree of multicollinearity. और अगर ये पूरा का पूरा एक ही सर्कल में आ जाए तो हम क्या कहेंगे, परफेक्ट मल्टीकोलिनियरिटी. So x1 and x2 here is showing perfect multicollinearity. Now I am giving you the example. Linear and non-linear relationship. Multicollinearity consider which type of relationship? Linear one. Now, multicollinearity refers only a linear relationship among x variable. It does not rule out non-linear relationship among them. For example, consider the model. That is what? Cost function. And cost function, what I am assuming, total cost is equal to beta 0 plus beta 1 q1 plus beta 2 q1 square plus beta 3 q यानी ये क्यूबिक फंक्शन है. और क्यूबिक फंक्शन है, इसका मतलब दिखने में ऐसा लगता है कि q1 q स्क्वायर एंड q क्यूब इंटर रिलेटेड है, बट दे आर नॉट लीनियरली इंटर रिलेटेड एंड देयरफॉर इट विल नॉट कॉज मल्टीकोलिनियरिटी. So it will not cause multicollinearity, and if your size of the sample is small, then there is a possibility of high degree of multicollinearity, but not the perfect. Sources of multicollinearity, an overdetermined model. If we want to estimate how much electricity used in family, this X should be the area of the household, the people of this house, the number of bedrooms, variables sharing the common time train. What is the reason for the multicollinearity? What we are assuming that y is a function of x1, x2, x3, then why x1, x2, x3 causes the multicollinearity? So there is the reason that x1, x2, x3 both are affected by the time. And since both are affected by the time and you are not including time, so there is a possibility that all these are interrelated and they can cause multicollinearity. Data collection method employed, for example, sampling over limited range of the variable taken by the regressor in the population. That can also dummy variable trap. Tomorrow we will discuss the dummy variable also. Dummy variable is very important. We are not able to measure something. For example, suppose we think that the salary is a function of sex. Salary is a function of sex. Can we measure sex? We cannot. We can use dummy variable for sex. If it is a male, we will say it 1, otherwise 0. In this way, if you proxy something, then that variable proxy, or you can say categorize the variable, then that is the dummy variable. And because of that, there is a possibility of correlation. Dominant variable. Sometimes multicollinearity is called that out of x1, x2, x3, is some variable is dominating, and it is the responsible for major impact, then that can also cause the multicollinearity. अब ये मैंने 2 एग्जाम्पल दिया है कि सपोज वी हैव ए 3 वेरिएबल रिग्रेशन मॉडल, 1 y डिपेंडेंट, x2 and x3 इंडिपेंडेंट, और उसमें आप देखिए कि परफेक्ट मल्टीकोलिनियरिटी So first issue of the multicollinearity is that the degree of sensitivity increases. What is the meaning of the degree of sensitivity? If you slightly change the sample, one observation or two observation, the result will change a lot, and you will be in trouble which result is more appropriate. So here is one example where R square is 0.81, and there is some change in the observation number 4, your result will change. Even R square will change. So the degree of sensitivity increases. Remember, when your degree of multicollinearity high, the OLS estimates are still blue, best linear unbiased. It will not affect the best linear unbiased, but unnecessarily it increases the standard error. And because of the standard increase in the standard error, the t value reduces. तो हम क्या कहेंगे, इनसिग्निफिकेंट बना देंगे, जबकि हकीकत में इनसिग्निफिकेंस क्यों आ रहा है? बिकॉज ऑफ हाई डिग्री ऑफ कोरिलेशन. एक एग्जांपल भी मैं ले रहा हूं, देखिए. The hypothetical data and the consumption, expenditure, income and wealth of the family. एक hypothetical data है, though one should not use econometrics when you have a hypothetical data, but still just to illustrate what is the consequences of multicollinearity. तो देखिए, we have regressed consumption expenditure on income and wealth of the family. Income and wealth of the family. So the estimated yield 24.77 is the intercept, 0.9415 is the coefficient of x2, and minus 0.0424x3 is the coefficient of wealth. Okay? और ये जो डिनोमिनेटर की वैल्यू है, ये सब क्या वैल्यू है आपकी? स्टैंडर्ड एरर ऑफ द कॉफी. देखिए आर स्क्वायर कितना है? 0.96, and even adjusted or corrected R square is 0.95. इसका मतलब क्या है कि 95% variation in food expenditure is explained by this model. 1. अब इसमें से आप देखिए कि अगर ये स्टैंडर्ड एरर, द कोएफिशिएंट डिवाइडेड बाय स्टैंडर्ड एरर निकालेंगे तो आपको टी वैल्यू मिलेगी. और देखिए दोनों में द टी वैल्यूज आर वेरी लो. पहले कोएफिशिएंट की टी वैल्यू कितनी आ रही है? 1.14, इनसिग्निफिकेंट. दूसरे वाले कोएफिशिएंट में टी वैल्यू कितनी आ रही है? 0.52, इनसिग्निफिकेंट. Very interesting case. Overall, the model is explaining 96% variation, but neither income nor asset or wealth is significant. Asset का भी impact नहीं है, wealth का भी impact नहीं है, income का impact नहीं है, but overall model is good. It is an indication of multicollinearity. It is a clear-cut indication of multicollinearity. Second thing. देखिए कि the impact of income on the consumption is positive. Marginal propensity to consume कितना आ रहा है? 0.94. Income और wealth का impact क्या आ रहा है? Negative, though insignificant. Is it possible कि wealth का impact consumption पे negative आए? Wealth should have a positive impact on this. So multicollinearity not only makes the coefficient insignificant, but sometimes it turns the sign of the coefficient. Positive से negative बना देते हैं, negative से positive बना देते हैं. Therefore, multicollinearity you have to check very carefully. ऐसा तो नहीं है कि R square बहुत अच्छा आ रहा है और some of the or most of the coefficients are not significant. ऐसा तो नहीं है कि hypothetically it should have a positive impact, but here we are getting negative impact. अब इसको हमने देखिए एफ वैल्यू निकालते हैं, सिग्निफिकेंस ऑफ द एफ, द आर स्क्वायर, वेदर आर इज सिग्निफिकेंट और नॉट. तो एफ वैल्यू निकालने के लिए क्या करते हैं कि सम एक्सप्लेन सम ऑफ द स्क्वायर डिवाइडेड बाय रेजिडुअल सम ऑफ स्क्वायर, ईएसएस डिवाइडेड बाय आरएचएस. और ये भी 92 आया है. एफ वैल्यू इज वेरी हाई. यू कैन से इवन द कोरिलेशन इज वेरी सिग्निफिकेंट. The coefficient of determination is very significant. So something is missing, and that is all because of the multicollinearity. अगर perfect multicollinearity होती तो ये regression के estimate आते ही नहीं, बीटा 2 बीटा 3 आते नहीं, 0/0 हो जाता है. अब आप देखिए कि अब इसको हम अगर separate regress करें in order to further investigate, कि कहीं हमारा जो नेगेटिव साइन है हकीकत में नेगेटिव तो नहीं है, तो व्हाट वी डिड, x3 को हमने x2 पे रिग्रेस किया। क्या किया, एसेट का इनकम के साथ क्या रिलेशन है, तो देखिए एसेट का इनकम के साथ पॉजिटिव रिलेशन है, हाईली सिग्निफिकेंट एंड आर स्क्वायर इज वेरी हाई, यानी मोर एसेट मोर इनकम मोर विल बी द एसेट, तो नेगेटिव इंपैक्ट नहीं आना चाहिए। और पॉजिटिव भी है और हाईली सिग्निफिकेंट, देखिए टी वैल्यू कितनी आ रही है, 62 आ रही है। Now what we are doing, we are regressing only consumption on the income, though there is a possibility of specification bias because you are ignoring some important variable, but still देखिए r square is 0.96, the coefficient is positive, highly significant, t value is 14, highly significant इसका मतलब income is positively affecting the consumption, asset is positive, income is positively affecting the wealth, तो वेल्थ का कोएफिशिएंट नेगेटिव नहीं होना चाहिए। फिर हमने क्या किया, x3 दैट इज वेल्थ को भी फूड एक्सपेंडिचर पर रिग्रेस किया, तो आप देखिए जी वी हैव रिग्रेस फूड एक्सपेंडिचर ऑन द एसेट और हियर आल्सो द कोएफिशिएंट इज पॉजिटिव, आर स्क्वायर इज वेरी हाई, क्या इंडिकेट कर रहा है, इसका मतलब impact of the wealth on the food expenditure should be positive, but when we combine these two variables into one regression model, we are getting none of the coefficient significant, and not only this, moreover the coefficient of wealth is becoming negative. It is all due to multicollinearity, and therefore there is a need to remove multicollinearity in the regression model. डिटेक्शन का सबसे अच्छा तरीका तो यही है कि हम कोरिलेशन मैट्रिक्स निकाल लें, जीरो कोरिलेशन मैट्रिक्स, बिकॉज मल्टी कोरिलेशन इज कंसर्न विद लीनियर कोरिलेशन, और अगर वो लीनियर कोरिलेशन है तो हम कह देंगे कि मल्टी कोरिलेशन है, हाई कोरिलेशन। दूसरा है कि एस्टिमेट निकालें, और इफ योर कोएफिशिएंट्स आर नॉट कमिंग एज पर योर थ्योरी और हाइपोथेसिस, you can say that there is a possibility of multicollinearity. Third, if r square is very high and most of the coefficients are not significant, then there is a indication of multicollinearity. फिर ये एक टेस्ट है, एप टेस्ट है, तो which we can use for multicollinearity, r I square, दो डिफरेंट रिग्रेशन रन करके, और हम उसकी वैल्यूज को निकाल सकते हैं, एफ वैल्यू, और you can use this one. Now how to remove, करें क्या जब मल्टीकोलिनियरिटी आती है, तो रेमेडियल मेजर क्या है हमारे पास, तो एक तो रेमेडियल मेजर है कि जो कोरिलेशन कॉज कर रहा है उसको ड्रॉप करो, वेल्थ इज कॉजिंग द प्रॉब्लम, रिमूव वन, और कोशिश ये करें कि get some information from the theory to what should be the relationship between the wealth and income. If you think that wealth and income has certain relationship and your wealth is 0.8% of your income, तो बहुत आसान है, फिर हम क्या करेंगे कि नया वेरिएबल बना देंगे, वेल्थ और इनकम को ज्वाइंट कर लेंगे। इंस्टेड ऑफ रिग्रेसिंग सेपरेटली, वी विल रिग्रेस ऑन द ज्वाइंट वेरिएबल, एंड ज्वाइंट वेरिएबल कैसे डेवलप करेंगे, Z is equal to income plus 0.8 of the income. So that will become a joint variable, and that joint variable will give the indication of this. दूसरा तरीका यह हो सकता है, increase the size of the sample. As I said, that multicollinearity is not the issue of the population regression model, it is a sampling issue. So somehow, because of your small sample, you are not able to remove the multicollinearity. Increase the size of the sample, multicollinearity will remove. Sometimes you can, for example, suppose you want to regress the consumption function, and consumption is also has a tendency to grow over time. Income also has a capacity to increase over a time, and wealth is also has a capacity to increase over time. So instead of dropping one variable, if you add trend variable into regression coefficient, dependent variable y is a function of x1, x2 and t, 1, 2, 3, 4, 5, trend value. तो trend का capture है, वो trend में चला जाएगा, and you will be relieved from the multicollinearity. So these are the ways of solving the problem. ड्रॉपिंग वेरिएबल करें, ट्रांसफॉर्मेशन ऑफ द वेरिएबल, अगर वो सिंपल है तो log में कन्वर्ट कर दीजिएगा, तो log में कन्वर्ट करेंगे, then there is a possibility that there will be no correlation. Add some new data, जैसे ट्रेंड को यूज कर लें, कंबाइनिंग डेटा इनकम और वेल्थ को कंबाइन कर लें, you can, and sometimes we can change the origin base. X1 and X2, they are correlated. So regressing Y on X1 and X2, it is better to regress change in Y. Delta Y on delta X and delta X2. So what we will do? Y2 minus Y1, Y3 minus Y2, Y4 minus Y3. So convert the data into incremental data. Incremental Y कितना है और सिमिलरली इंक्रीमेंटल इनकम कितनी है, इंक्रीमेंटल वेल्थ कितना है. तो ओरिजिनल डेटा देयर इज अ पॉसिबिलिटी ऑफ हाई डिग्री ऑफ कोरिलेशन, बट इफ यू वर्क आउट द इंक्रीमेंटल डेटा मींस डेल्टा वाई रिग्रेस ऑन डेल्टा x1 डेल्टा x2, देन देयर इज a possibility of no correlation. So third is the problem of multicollinearity, what we discussed. The expected value of u is equal to 0, not 0, not normally, what will be the implication? Then variance is not constant, what will be the implication? If there is a high degree of correlation between x2 and then what will be the issue? So high degree of correlation, multicollinearity. Perfect है तो don't bother, because your estimation methods break down 0 upon 0 indeterminate. But if there is a high degree of multicollinearity, you will get the calculation. They are still true, best linear unbiased, but your interpretation will be wrong. Why? Because multicollinearity unnecessarily increases standard error, and increase in standard error reduces the t-value, and therefore the interpretation of significance will be changed. And how to change it? So whenever you are using, whether it is cross-section data or time series data, there is a full possibility of multicollinearity in multiple regression model. Why full? Because most of the time economic variables behave in the same direction. There is a possibility of correlation between the different economic variables that is there, और हटाने का या उसको रिमूव करने का बहुत आसान तरीका है. स्केल चेंज कर दें, स्टैंडर्डाइज कर दें, इंडेक्स में कन्वर्ट कर दें, एब्सोल्यूट वैल्यूज को इंडेक्स में कर दें, लॉग वैल्यूज में कन्वर्ट कर दें, और डिविएशन फॉर्म में, इंक्रीमेंटल फॉर्म में निकालें, इंक्रीज द साइज ऑफ द सैंपल और ड्रॉप सम ऑफ द ऑब्जर्वेशन. यू कैन चेंज द और यू कैन रिमूव द मल्टीपल. नाउ द next one and the most important is the autocorrelation. Concept क्या autocorrelation का? Consequence, causes for autocorrelation, consequences of using OLS in the autocorrelated model क्या है, and detection क्या है, और remedial measures क्या है. हर जगह कितना इकोनॉमेटिक्स इज सो सिस्टमेटिक. इकोनॉमिक्स की कोई भी ब्रांच इतनी सिस्टमेटिक नहीं है. मॉडल बनाया, अजम्पशन दिया, एक एक अजम्पशन को ड्रॉप करो, एक एक चैप्टर बन जाएगा. चैप्टर स्पेसिफिकेशन बायस, चैप्टर मल्टीकोलिनियरिटी, चैप्टर हेटेरोसेडेसिटी, चैप्टर ऑटो कोरिलेशन. और हर चैप्टर में आपको क्या डिस्कस करना है? कंसेप्ट क्या है, कॉज क्या है, कॉन्सिक्वेंसेस क्या है, डिटेक्शन क्या है, और फाइनली रेमिडियल मेजर्स क्या है. तो इसको सिस्टमेटिक. तो पहला कंसेप्ट समझ में आ जाए कि व्हाट इज यू, what are the assumptions of U, what is OLS, why we are using OLS, then the development of econometrics is very systematic and you can learn it very easily. The concept, the correlation between the members of the series of observation order in time or space is all. Means we are working out the correlation not between the two variables but with the same variable. x1 we are correlated with x minus 1, एक साल का लेट. आज का x2 we are linking with x1, x3 we are linking with x2, X4VR मतलब एक साल पीछे की ऑब्जर्वेशन ले लें तो that is known as serial correlation, and serial correlation is also known as auto. The term auto correlation and serial correlation are usually interchangeable. कई जगह आपको बुक में serial correlation मिलेगा, कई जगह आपको auto correlation. However, some authors prefer to distinguish between them. We will use both terms simultaneously in this lecture. Pure serial correlation. Pure serial correlations occur when classical assumptions hold, which assumes uncorrelated observation of the error term is violated. That is, you have a regression model, and in X1 is causing one distribution of U, X2 is causing another distribution of U. What we are using, that these two distributions are independent, then that is known as non-autocorrelation. If they are interrelated, that is, the error generated because of the low income families, error generated because of the high income family, if they are interrelated, then there is a problem of autocorrelation. And most of the time, autocorrelation is a problem of time series. Autocorrelation is a problem of time series. And heteroscedasticity is a problem of क्रॉस सेक्शन. बड़ी तकलीफ है. क्रॉस सेक्शन यूज करें तो ये प्रॉब्लम आ जाती है, टाइम सीरीज यूज करें तो ये प्रॉब्लम आ जाती है. तो वी हैव टू बी वेरी कॉन्शियस. So the pure autocorrelation, Covey phenomena, you must be knowing that the current price is a function of past price. So if you have a linking the over a time period, you are linked that your error term is influenced by last year's observation, then there is a possibility of autocorrelation. Data manipulation. Sometimes we manipulate data, and that is very common practice. नहीं मिल रहा है 10% बढ़ा के लिख दो भाई, लास्ट ईयर इतना था, इस साल इतना हो जाएगा. When I was working with the State Planning Commission, and you must be knowing that in all state Directorate of Economics and Statistics is almost dismantled. They are not working properly, whatever is available on the website. And that's why the companies like Center for Monitoring Indian Economy, they are earning huge revenue because they are collecting information and they are providing. So when they ask me that develop a formula of deviation of fund, which I presented yesterday, so some of the information I was not getting for some districts. So then I requested the vice chairman of State Niti Aayog. He instructed the commissioner of Directorate and Economic Statistics to provide these reports. और अल्टीमेटली से सर बाकी नहीं मिल रहा, आप लिख लीजिए ना सर, वहाँ इतना था तो 10% बढ़ा लीजिए, कहीं 5% बढ़ा लीजिए, क्या फर्क पड़ता है, कौन सी सैलरी जा रही है. So if you are manipulating data, then there is a possibility of autocorrelation. Interpolation, again there is a possibility of autocorrelation. Extrapolation, there is a possibility of autocorrelation. So if you have some missing observation, it is better to drop them. Don't interpolate it, don't manipulate it, don't extrapolate it. That's why econometrics require actual data. If you are just manipulating data, some formulas, by y is equal to 10x, then possibility there will be a autocorrelation. So the interpolation is not allowed, extrapolation is not allowed. देखिए, this ut या et is equal to rho times ut minus 1 plus vt. This rho is what? Rho is nothing but degree of autocorrelation. क्या बता रहा है कि current error term is influenced by last year's error term. तो इसको हम कहेंगे कि फर्स्ट ऑर्डर, अगर इसको हम कहेंगे et is equal to rho times et minus 2, यानी करंट एरर इज इन्फ्लुएंस्ड बाय 2 साल पीछे की, देन दैट इज नॉन एज सेकंड डिग्री ऑटो कोरिलेशन एंड सो ऑन. So auto correlation maximum less than 1, minimum less than -1, it lies between -1 and +. So it may be a positive autocorrelation, it may be a negative autocorrelation. ग्राफिकली अगर हम एरर टर्म को टाइम के ऊपर प्लॉट करें और एक सिस्टमेटिक पैटर्न बने, all small values small, then increasing value, then there is a possibility of autocorrelation. इस तरह का पैटर्न बने तभी there is a possibility of autocorrelation. Impure autocorrelation क्यों आता है? Wrong functional form है, omitted variables है, proper manipulated data है, interpolated data है, तो then there is a measurement error है, हम income को measure कर रहे हैं उसमें error है, और इसलिए प्राइमरी डेटा जब आप कलेक्ट करें तो बी केयरफुल. आप ये पूछेंगे आपकी इनकम कितनी है, यू विल नॉट गेट ए प्रॉपर आइडिया ऑफ द इनकम. यू हैव टू सर्च सम मेथड ऑफ कलेक्टिंग द इनकम, अदरवाइज इट विल कॉल autocorrelation. Now this is the true equation, yt is equal to beta 0 plus beta 1 x1 plus beta 2 x2, and this is the error term. There is a classical error term as shown in the section this. The error term is therefore is not classical error term. Instead, the error term is also a function of one of the exploratory variable x2. As a result of the new error term, the link between these two is the converted into this one, the graph. You can see the x values and y. In the earlier graph, what we did, we plotted only the error term over time. But here we are plotting the y or x, और पैटर्न स्कैटर डायग्राम अगर इस तरह का है और एस्टिमेटेड लाइन हमारी ऐसी बन रही है, तो क्या क्वाड्रेटिक रिलेशन है, यू शेप रिलेशन है, लेकिन व्हाट वी आर assuming linear relationship, then there is a possibility of autocorrelation. Same is the picture here. अब क्या मतलब, suppose there is a autocorrelation, we still applying OLS, what will be the consequences? So remember, pure or serial correlation does not cause bias in the coefficient of the estimation. And still beta 0, beta 1 will be unbiased. It is not causing bias. It is unbiased. And what is the meaning of the unbiased? What is the meaning of the unbiased? So if you repeat the sampling procedure and suppose you have n sample, for n sample you will get n number of beta 1. So if you take the average of the betas, beta 1, you will get equal to the population parameter, and therefore it is unbiased. Mean is unbiased. Standard deviation is not unbiased, it is biased. And in order to make a standard deviation biased, instead of dividing n, we divide it by n minus 1. दूसरी प्रॉब्लम ये कि अनबायस्ड तो हो जाएगा, बट द वेरिएंस इज नॉट मिनिमम एंड देयरफॉर इट इज नॉट ट्रू. बेस्ट लीनियर अनबायस्ड नहीं. तो जब हम वेरिएंस निकालेंगे तो अगर ऑटो कोरिलेशन है तो द वेरिएंस विल नॉट बी मिनिमम एंड देयरफॉर यू विल से इट इज नॉट ट्रू. अब उसको कैसे हैं, ये हमने सिस्टम है हाउ टू टेस्ट के लिए लिंक कर रहे हैं, because this year error is affected by last year and last year error is affected by further last year and so on. इसको रिग्रेशन सिस्टम में किया तो ये फाइनली मैट्रिक्स फॉर्म में बनता है. सिग्मा यू स्क्वायर डिवाइड बाय 1 माइनस रो स्क्वायर मल्टीप्लाइड बाय एक्स ट्रांसपोज इनवर्स मैट्रिक्स. Sigma u square, and this rho is nothing but the degree of autocorrelation. The degree of autocorrelation is the denominator. So you can say, because of the degrees of the autocorrelation, your variance will increase as the value of autocorrelation increases. 1 minus rho square, difference will be smaller. As your rho value increase, 1 minus rho square will be smaller, and sigma u square divided by smaller number, so it increases द वेरिएंस, और अगर आपका वेरिएंस बढ़ जाएगा तो क्या होगा, द एस्टिमेटेड वेरिएंस ऑफ द एरर इज लाइकली टू बी ओवर एस्टिमेट द ट्रू वेरिएंस. Overestimates of the R square, even R square will be overestimated, and therefore we have to be very careful about the presence of the autocorrelation. कई सारे मेथड्स हैं ऑटो कोरिलेशन को डिटेक्ट करने के लिए, और सबसे कॉमन मेथड है डर्बिन-वाटसन टेस्ट. और जो ही आप रिग्रेशन रन करेंगे सॉफ्टवेयर पे, आप चाहे इंस्ट्रक्शन दें ना दें, वो आपके नीचे बीटा 0, बीटा 1, स्टैंडर्ड एरर, आर स्क्वायर और डीबी वैल्यू भी डर्बिन-वाटसन वैल्यू भी निकाल के दे देगा. तो आपको जज करना है कि ऑटो कोरिलेशन है या. ग्राफिकल मेथड है. सबसे पहला तो सिंपल पार्ट है. देखिए एक सिस्टमेटिक पैटर्न बन रहा है, ये भी सिस्टमेटिक पैटर्न बन रहा है, यहाँ कोई सिस्टमेटिक पैटर्न नहीं है, ये भी सिस्टमेटिक पैटर्न है. तो दैट शोज द प्रेजेंस ऑफ ऑटोकोरेलेशन. डिटेक्शन के लिए सिंपल y को आप x पर रिग्रेस करें विदाउट एज्यूमिंग ऑटो कोरिलेशन. बीटा 0 निकाल लें, एरर निकाल लें, y कैप माइनस y, e1, e2, e3 निकाल लें, और उसके बाद ये डर्बिन वैल्यू निकाल लें, et माइनस et माइनस 1. difference, successive difference of the error term, successive difference of the error term, e2 minus e1, e3 minus e2, e4 minus e3, और उनका स्क्वायर करें, टोटल करें, और स्क्वायर करके टोटल आए उसको न्यूमरेटर में रखें, समेशन ई स्क्वायर को नीचे रखेंगे, और ई वैल्यू जाएगी डी वैल्यू, और इस डी वैल्यू को टेबल वैल्यू से कंपेयर करेंगे. इफ योर डी वैल्यू इज क्लोजर टू 0, thank God there is no autocorrelation. If it is equal to more or less 2, greater than 1, or is around 4, then there is a possibility of positive autocorrelation or negative autocorrelation. ये assumption है डर्बिन-वाटसन टेस्ट में. एक बहुत इंपॉर्टेंट मॉडल है जिसको हम कहते हैं डिस्ट्रीब्यूटेड लेग मॉडल. Distributed leg model means your consumption is not a function of your current income, your consumption is a function of your past consumption. आदत जल्दी से नहीं बदलती. कोविड आ जाए तो ऐसा नहीं कि इनकम कम हो गई तो कंजम्पशन 0 हो जाए. इट टेक सर्टेन टाइम. तो इकोनॉमिक्स में कई सारे मॉडल डिस्ट्रीब्यूटेड लेग मॉडल पे काम करते हैं, और डिस्ट्रीब्यूटेड लेग मॉडल की सबसे बड़ी वीकनेस है कि यू कैन नॉट यूज डर्बिन-वाटसन टेस्ट. You have to revise the test for the autocorrelation. और econometrics में the use of distributed leg model is very high. गोल्ड की प्राइस अचानक नहीं चेंज हो जाएगी, पूरा का पूरा पास्ट पैटर्न कैसा है, रिलायंस के शेयर का पास्ट पैटर्न कैसा है, ऑल. तो डिस्ट्रीब्यूटेड लेग मॉडल इज वेरी इंपॉर्टेंट, और उसकी सबसे बड़ी लिमिटेशन ये है कि डर्बिन-वाटसन टेस्ट इज नॉट यूजफुल इन द. तो Heil and Nagar modified the Durbin-Watson test. Nagar is the econometrician of India. Heil, a wonderful econometrician. They jointly developed one test, and that can be used. So those who will take some advanced course in econometrics, all they will come across this one. और आपके लिए बढ़िया है कि सॉफ्टवेयर में वो डी टेस्ट निकाल के दे देगा. आपको केवल इंटरप्रेट करना है कि ऑटो कोरिलेशन है या नहीं है, और है तो फिर मॉडिफाइड रेमिडियल मेजर्स भी आ जाएगा. ये टेबल वैल्यू है डी की, आपने एस्टिमेटेड वैल्यू की है, और ये क्या है, इसमें डी एल लोअर लिमिट है, अपर लिमिट है, और अगर आपकी डी अनफॉर्चुनेटली लोअर और अपर के बीच में आ जाती है तो योर डिसीजन इज इनकंक्लूसिव. यू हैव टू रिपीट द एस्टिमेशन प्रोसेस बाय एडिंग सम मोर इंफॉर्मेशन और ड्रॉपिंग सम ऑफ द observations, then only you will be able to judge. ये देखिए 0 के लगभग है पॉजिटिव ऑटो कोरिलेशन, 2 के लगभग है नो ऑटो कोरिलेशन, और 4 के लगभग डी की वैल्यू है, इसका मतलब नेगेटिव. और ये पॉजिटिव ऑटो कोरिलेशन, नेगेटिव ऑटो कोरिलेशन के बीच में नो ऑटो कोरिलेशन की रेंज है रिजल्ट वो जो मैंने आपके साथ डिस्कस किया सेम, और ये टेस्ट रिवाइज किया, उसमें एज टेस्ट निकालते हैं और ये एज टेस्ट की वैल्यूज हैं। ये एक और टेस्ट है ऑटो कोरिलेशन का, बट नॉट वेरी पॉपुलर, ये भी एक टेस्ट है। नाउ आई एम कमिंग टू द रेमेडियल मेथड। जब ऑटो कोरिलेशन आ जाए तो क्या करें? सबसे सिंपल तरीका, ऑटो कोरिलेशन आ जाए तो ये मान लें सबसे पहले कि देयर इज अ परफेक्ट कोरिलेशन। ऑटो कोरिलेशन 1 है, और 1 है तो आप क्या करें, सक्सेसिव डिफरेंस निकाल लें। y2 माइनस y1, y3 माइनस y2, y4 माइनस y3, x2 माइनस x1, x3, यानी x और y जितना भी इंडिपेंडेंट वेरिएबल है, जितना भी डिपेंडेंट वेरिएबल है, उन सबके सक्सेसिव डिफरेंस निकाल लें और सक्सेसिव डिफरेंस को रिग्रेस करें तो काम बन जाएगा। ऑटो कोरिलेशन विल बी। द सेकंड पार्ट इज दैट आपने डी वैल्यू निकाल दी और डी वैल्यू से डिग्री ऑफ ऑटो कोरिलेशन निकाल, डर्बिन वैल्यू तो आ गई और डर्बिन वैल्यू में से सब्स्टिट्यूट करके रो की वैल्यू निकाल लीजिएगा ऑटो कोरिलेशन कितना है, और उस ऑटो कोरिलेशन को यूज करके एक वेटेड वेरिएबल क्रिएट कर लीजिएगा। तो वाई टी माइनस रो टाइम्स वाई टी माइनस 1। सिंपल सक्सेसिव डिफरेंस निकालने के बजाय वेटेड डिफरेंस निकालेंगे। सक्सेसिव डिफरेंस निकालने हैं, ऑटो कोरिलेशन को 1 मान के। सपोज ऑटो कोरिलेशन इज 0.8, तो हम क्या करेंगे, वाई टी माइनस 0.8 टाइम्स वाई टी माइनस 1, एक्स टी माइनस 0.8 टाइम्स एक्स टी माइनस 1। तो वेटेड डिफरेंस निकाल देंगे और वो वेटेड डिफरेंस रिग्रेस करेंगे, द ऑटो कोरिलेशन विल बी रिमूव्ड। और इंक्रीज द साइज ऑफ द सैंपल, कई बार हम सैंपल साइज इंक्रीज करें तो ऑटो कोरिलेशन रिमूव हो जाएगा। कई बार मिडिल वैल्यूज में से जो बहुत एक्सट्रीम वैल्यूज आ रही हैं उनको ड्रॉप करके भी हम निकालते हैं। ये देखिए, ये मैंने कहा ना, वाई टी माइनस रो टाइम्स वाई टी माइनस बीटा 0 1 माइनस रो टाइम्स 1 माइनस रो प्लस बीटा 1 एक्स 1 टी माइनस रो टाइम्स एक्स टी माइनस 1, केवल वेटेड। अगर परफेक्ट है ऑटो कोरिलेशन तो रो की वैल्यू क्या बन जाएगी, 1, केवल सक्सेसिव डिफरेंस, और इनको रिग्रेस करें। बस याद रखिएगा ये बीटा 0 इज नॉट ए सिंपल बीटा 0, इट इज द इंटरसेप्ट बीटा 0। तो एक्चुअल बीटा 0 निकालने के लिए क्या करना पड़ेगा, ये जो इंटरसेप्ट है डिवाइड बाई 1 माइनस रो, यू विल गेट ए ओरिजिनल वन। पर बीटा 1 के केस में कोई प्रॉब्लम नहीं है, द सेम कोएफिशिएंट विल वर्क। तो ये स्टार लगा के हमने नया वेरिएबल बना दिया वाई टी माइनस रो टाइम्स वाई टी माइनस 1, तो ये नया निकाल दिया और उसको आप रिग्रेस करें, यू विल गेट द वैल्यू ऑफ बीटा 0 एंड बीटा 1। तो रो की वैल्यू कैसे करें, और कोरिलेशन है डर्बिन वैल्यू, यहाँ अगर आप रिप्लेस करेंगे तो रो की वैल्यू आ जाएगी एंड दैट यू कैन यूज फॉर दिस। कई बार it is better to assume -1 as a 1. मोस्टली पॉजिटिव ऑटो कोरिलेशन होता है, पर कुछ केसेस में माइनस होता है, तो माइनस हो जाएगा तो हम वाई टी माइनस 1 लेंगे तो माइनस माइनस विल बिकम प्लस। तो टेक द मूविंग एवरेज ऑफ 2, टेक द मूविंग एवरेज y1 प्लस y2 डिवाइड बाई 2, y3 प्लस मूविंग एवरेज में क्या करते हैं, एक एक करके बढ़ाते जाते हैं। तो इंस्टेड ऑफ रिग्रेसिंग सिंपल y ऑन x1, इट इज बेटर टू रिग्रेस मूविंग एवरेज ऑफ y ऑन मूविंग एवरेज ऑफ x, यू विल बी एबल टू रिजॉल्व द प्रॉब्लम। ये देखिए सिंपल डिफरेंस निकाल दिया, और जो आप सिंपल डिफरेंस निकालोगे इंटरसेप्ट विल डिसअपीयर, आपकी वैल्यू सीधा रिग्रेशन कोएफिशिएंट आएगा, नो इंटरसेप्ट। So thank you all. This is about the relaxing the assumptions of OLS, or the use of this is that once you are using regression line, OLS method, be careful that there are certain issues. So before interpreting the result, try to resolve the issues of the regression and then interpret. ऐसा नहीं कि regression निकाल दिया कुछ हो गया, ये बीटा 1 आ गया, बीटा 2 आ गया, R square इतना अच्छा आ गया है. तो there are some issues और उन issues को ध्यान में रखकर interpret करेंगे तो you will become a wonderful researcher. Econometrics is a wonderful tool. Those who know economics, बहुत refinement आता है और रिसर्च के कई सारे एरियाज खुल जाते हैं. ड्रॉप वेरिएबल करें, ऐड कर दें, एक नया पेपर बन जाएगा, इंडेक्स निकाल दें, एक नया पेपर बनेगा. और अभी जो मेजर वर्क आ रहा है ऑल एस्टिमेटेड इक्वेशन. कई बार तो जर्नल्स अगर आपने कोई एस्टिमेट नहीं किया तो एक्सेप्ट ही नहीं करेगा पेपर. empirical is very important. So thank you. Now it's open. If you have any issues, discussion, you are most welcome. अब 2 issues और रह गए हैं, एक तो डमी वेरिएबल, एक नॉन लीनियर रिग्रेशन. टुमारो वी विल ट्राई टू कवर दिस 2 और फिर थोड़ा टाइम बचेगा तो रिसर्च की भी बात करेंगे. यस
सर. हेलो.
पार्डन, थोड़ा तो लाउडली बोलो, आगे आ जाओ. देखिए कौन सा मेथड बेस्ट है इसके लिए कोई डायरेक्ट होती नहीं है. आप प्रॉब्लम मल्टी कोऑर्डिनेटिव को रिजॉल्व करना चाह रहे हो या ऑटो कोऑर्डिनेशन को रिजॉल्व करना, दोनों प्रॉब्लम एक साथ रिजॉल्व नहीं. ठीक है, तो अगर मल्टी कोऑर्डिनेटिव को रिजॉल्व करना है तो सम टाइम टेकिंग लॉग विल सॉल्व द प्रॉब्लम ऑफ मल्टी कोऑर्डिनेटिव, क्योंकि आपने नेचर ऑफ रिलेशनशिप चेंज कर दिया. बट व्हेन यू वांट टू डू द ऑटो कोऑर्डिनेशन पार्ट, log will not help. You have to take successive difference या मूविंग एवरेज डिफरेंस. log निकालने से the auto correlation की नेचर चेंज नहीं होती. ठीक है, तो there are 2 different issues. Multicollinearity, take log, it will serve the purpose. It may serve the purpose, not necessary. और auto correlation है, if you take the log, it will not solve the problem. When auto correlation, you have to go for successive difference or moving average difference या weighted difference, depending on the value of auto correlation. ठीक है, कुछ पूछो. वैसे तो बहुत आज सेकंड सेशन में क्या एस्टिमेशन है, कुछ आर का आप लोग हैं. अच्छा कर देंगे.
Sir, am I audible?
Yeah.
Sir, can we calculate? Can we do GLS on a cross-sectional data?
Wow. GLS means the generalized least square method.
Yes.
And in the cross-sectional data, if there is a problem of heteroscedasticity, we have to use generalized least square method. We don't have any other method.
You can use the standard error, robust standard error. So if you correct the error, then we can use also cross-sectional data.
Standard error means we have to improve the standard error.
Yes.
And for improving standard error, what is the way? We have to reduce the variable, and reduction in the variable means we have to divide either by the x values or x square value, depending on what is the nature of relationship between the variance of the error term and the independent variable.
Okay.
Okay.
Sir, actually in GLS, what we do in weighted least square, okay, you have told that to remove the heteroscedasticity, we can do the weighted least square. Okay, we can assign some weight to the variables.
Yeah.
But in general least square, what exactly has done to remove this problem of heteroscedasticity?
Generalized least square, actually when you are reducing the variable and then regressing, it is nothing but generalized least square method.
Okay, sir. Thank you, sir.
Right. और कोई हो ऑनलाइन क्वेश्चन?
Respected Professor Kavadia, my colleague, and dear participants and students. Before I, propose a thanks for the session, sir, while sitting there, because this is the longer time I've been here, so just I was recalling the days when these are the days of 2002 to 4, when we sit into the classroom. And the difference was only this, that the teacher, Professor Kundu particularly, they use this OHP. So they come up with that transcripts and they put me into that difference is only this. And I was just, just recalling and enjoying the same sort of understanding, which the the classical and a well-established version of teaching is there. So, because nowadays, the scenario is different. But the way you are delivering the things, it is just, enriching our mind to understand in more better and better way. So, it's really wonderful, sir. We are very thankful to you for this particular session and otherwise also. And you have very beautifully mentioned, it's, however, you understand that it is very, hard to make people understand without doing the derivation actually. We have to, students should understand that how this row has to be estimated, how heteroscedasticity, presence of heteroscedasticity has to be estimated. So there are so many equations, derivations are there, but you have very beautifully explained the concepts, and I'm sure these young minds have a good idea, good understanding, and it was like that actually the Gujarati is in front of us and we are having the similar sort of understanding. So thank you, sir. Thank you very much for your time and, for this deliberation. And we look forward for tomorrow also. Thank you all. Thank you very much.
हेलो ठीक है उसके लिए मुझे ये चालू करना है अच्छा ठीक है बस और कुछ नहीं करना ना फोन रखा रहना तो कोई डिस्टरबेंस नहीं होगा मैं साइलेंट कर रहा
नहीं
हाँ हाँ
इस पे भी दिखाना है।
हाँ तभी तो उनको दिखेगा
इसके लिए ना इसमें है कुछ HDMI वगैरह।
हाँ
HDMI लिख देगा।
अच्छा यहाँ पे तो मैं शेयर कर लेता हूँ चलो पहले आप लगा दो वहाँ रख लो लैपटॉप हाँ कोई दिक्कत नहीं अब देखो
Sir, we are not getting your voice.
सर्व कर दो इसमें।
इस पे स्क्रीन शेयर कर रही है ना अच्छा ठीक है मैम मे आई स्टार्ट
So good afternoon, Renu ma'am, and dear participants, very good afternoon. Thanks to organizers for inviting me in this workshop, and really it is very pleasant and wonderful experience to see face to faces. It was just tough time last 2 years that we were not able to meet face to face, and constraint of the online especially is that we just start our presentation or lecture and something in phone and put it in pocket and go for tour. So at least here we can see faces to each other and expressions of your faces, my faces also. So let us start. Just it is just first one is the introductory. I have made this presentation in this software R Studio. Is it visible from the last one, or may I increase the size it for it? Let me first tell you. May I start from the very beginning? First, we just download the R software. We can install it easily. It is a very light software, about 86, 80, 88, 89 MB software. And even it takes space from the space on the C drive only around 200 MBs, not more than 200. After that, we can work directly on R. But when we work on R, we need more skills and more requirement to learn commands. Therefore, a team prepared this R Studio. It works like a studio, and here engine is R. So now let's increase the size of this one. These are some options. We can play with them. So we may zoom it, like say this one. I think now is it visible? So let first show you just introduction about the R. I'm not going into detail about the R because otherwise we will not work on it. We have limited time. I have shared with these slides with you so you can see it. Just the most important thing what I usually say with especially my students as well as others, many user things are as a statistics software or system, but it an environment within which statistical techniques are implemented. Basically, we have data and we need to analyze data. Some tools we have already SES, we have already SPSS, we have already Stata. All these are good softwares, very good softwares. The main concern is the money, and many people don't have money to buy these softwares. As being the research scholars, even I have faced these situations that if you are writing in your research paper that you have used SPSS, and sometimes you can get even notice that do you have license. So such type of issues are there. Another thing is that those are like menu driven softwares. You are to put the data, you are to insert the data, just click click click, and finally you get your results. You don't know what is going on behind those commands. So even sometimes we feel that if we want to some such analysis for the that analysis commands are not available in a particular software. So in R we can easily make those commands with the help of the programming. So these are some features, and why are these I have written like till now there are 18,979 libraries are available, freely available, even tested libraries. Even more than 20,000 libraries are available. Those are not tested. Only 18,979 libraries were available till yesterday. These are the tested libraries, and even 38 views, task views, especially if you want to work on the, let me show you just one thing, because like we want to study econometrics. चलो इसमें आगे चलते हैं. These are some limitations. Even these limitations show that how beautiful is the R. I'm skipping it. And what is the R Studio? R Studio is just the facilitator for R. Their R work as an engine. It was founded in 2009. Even commercial version of R Studio is also available for companies. And they have provided free version also, which is known as popularly desktop version, which we can easily download and install. Again, it is of size around 120 MB like that. And what are the beauties of this R Studio software? We will see in few slides. Let me show the layout. These are the basic. This is the first one. This is like a script. We can write here our codes, and we can save these codes for the future. This is the console, R console, where analyzes work done. And here are some like environment, history, files, etc. Even we can change with the help of these global options. Appearance, you can see appearance. Okay, you can see pane layout. Such sources are available. This window can be divided into 4 parts, and according to your situation, according to your requirements, you can put all these things here. So next come like R script environment, graphical outputs, etc. I have given this link for especially for if you want to learn some more about the R. Now comes on to the software. Even you can open, you can make a file. By the way, this file is already built with the help of the R Studio. Now just what we do, we can use R as a calculator. If you want to add some numbers, you can easily add. If you want to subtract, multiply, exponent, that is powers, you can do all these things just like that. This is the R console. How I made this file, just let me show you one thing. Here is the new file. If you click on this new file, then you will have like R sweep. I have made this file with the help of the R sweep, but it requires LaTeX software. That's why sometimes it don't work in directly computers. You can make this file in such a way. Even there is a software Tinitech which is available with R Studio. Like here, these are the packages on the right hand side. This one you can install directly from here. Any package what we require. So first we start the basics, then we will come on these filing systems. So we can just write like on the console, we can write 2 plus 2 like just 4, 1 minus 2 for example like -1. In such a way we can run all these things. In the R Studio, this is the script file, or you can say sweep file. we have typed already all these things here, and just with the help of the control plus enter, here the command is control plus enter, or simply click here run on the run, this one. If you put like what you want to run, just click on this one, run selected files, selected lines, or just simply you can use control plus enter. Put the finger on the control and enter like this one. You will have output on the console in such a way. Another thing is that, most important thing is that these are the basic things. You can use R as a calculator, you can use R as a graphical interpreter, even if we want to generate some sequences. So we have 2 to 3 functions. One is just say we have this column function. Just put these 2 points like column, enter, we have this sequence. Another function, we have seq. So this one, like just this one. Another function is seq from 2, and even we have another 2 arguments here, length. If we need, suppose seq, say from 1 to 10, so we will have such facility. Even we need 1 to 10 and length equal to say 100, then we will have these 100 numbers, equally divided 100 numbers between 1 to 10. Okay. Another thing is that we have another command, say by. Another argument is by. Increment or decrement. Say increment is 2, then we will have 1 plus 2 plus 2 plus 2 like that, up to obviously 10. Even suppose we want to find out the decreasing series, then we will have okay. So it is not the increment, put the minus here. So you will have decrement also. According to your requirement, you can generate the sequence. These are some basic functions. Now, say sometimes we required decimals, places of the some places after decimal. So we have the function round. Obviously, this is the same as work in Excel file. Now we have, for example, x2. This is the x2, and now I want to put decimal after. We need only 2 digits after decimal, so we can put round here. If we put here 0, see, okay, if we put here say 5, then we will have 5 digits after decimal. So this is the round function here available. Another one is repeat function or replicate function. Say just let me show you this one. This is the sequence, not sequence. We have a data set. Just see, replicate to 1 time. First one, how much? First one is the observation which we want to replicate, and second argument is just how many times. See, 1, suppose 10, then we will have 10 times 2. Even we can replicate these things. So suppose we have more data set. See, I have a data set, say A equal to 1, 2, 3. Then we will have A 3 observations in this A. I have a data vector or a data set with the name A, and I want to replicate it 2 times. Just put here replicate A2. Just see 1 2 3 1 2 3. Suppose I want to replicate it 10 times. Then we will have 10 times replication. So this is the another command for replication, and there is a for loop also. Now suppose we have 2 data sets. I know that this data import and export is the very important. Usually what we do, we put our all data in Excel file, and we are very familiar with the Excel. So that will be the most important, but we will go at that step after some time. First, just basics of R. What are the basics? I made a vector, say x1. Let me show you what is x1. This is the x1. Say y1, and this is the y1. Now I want to combine. So just club with the help of C function, C, and the argument is x1 and x2. If you have say A also here, because we have A already. Even how we can see that what is going on? So that's why we have environment. This is the environment. A numbers 1 to 3, x7, x2 numbers 1 to 20, y1 numbers 1 to 7. Function is square, function is available here. We will see after some time. Even we have history also, what we are performing. You can easily see. If you don't remove it, then we will have history also. Like, even we have files also where it is working and what files are available. So come to the point. So now we have this one Z. Let's see what is the Z. So in the Z we have A, x1 and x2, whatever the size. By the way, most important thing is that size, purely size of this R software depend on the RAM of your computer. Whatever size of your RAM, then that much of data you can work on it. It is not hard. If you have 4 GB RAM, then your R software can work with the load of that data that is applicable for 4 GB RAM. It's purely depend on the RAM. As you increase your RAM, then you can increase. By the way, we don't do such type of work that we required a lot of data. Lot of means 4 GB or 5 GBs data. Usually we work on MBs, KBs and MBs. So another thing is that cbind. Another function is cbind. So let's see what is the cbind. Let me change it. Say another is A. I have put say A is also here. Okay. Because what is the problem here? Size of the x1 1 to 7. Size of y1 say this one, and size of A is 1 to 3. Okay. So that's why size is different here. If we define A, again A, say A equal to say 10 to 16, then A will have these numbers. Now you can check in such a way. Even you can combine your data column wise. Let's move further. Creation of the data vector. So this is the simple most thing. Obviously, if we have large data, we don't write here in the R software. In the अच्छा अच्छा तो मुझे लगा कि मैं फाइल भेज चुका हूँ कि फोटो अच्छा मैं यही वाली फाइल भेज दूं ना आपको तो आसान हो जाएगा, आरएनबी फाइल भेज दूं, डायरेक्टली ओपन कर लेना ना, साथ साथ करते रहोगे। You can directly put this file into your folder and you can open it. You can start practicing on this file. Please open it in RStudio. And it requires a lot of internet, but don't worry, don't install at this time software, otherwise you will stuck. No, just click, double click on it. It will be directly open. Put this file into your folder, in which folder you are working, and just double click, open it. It will be opening directly in RStudio. So let me start. Is it open or not?
Sir, please wait a minute.
Just see. Please listen to me, please. Just see. Whatever this is written here. These are all LaTeX commands. So please don't see these commands. You are to see only chunks. What are the chunks here? These are chunks which are closed between, let me show you, which are closed between this one and this one. Whatever written between these two things, that is especially for R software, especially R. And this will be calculated, and all the remaining material will be just type. It is nothing but just typing. So you are to focus on it at this time. At this time, you are to focus only on these things. Stuck somewhere? Otherwise, another good way is just make a new file, R script. This is the simple most thing. Just type here like 2 plus 2, control enter. Another thing, say what we are considering like a equal to like this one, control enter, like this one. The simple most thing is that here. May I move further, or do you want to ask something? Till now we were here. C bind. This is the output file after running that RNB file.
Sir, this file was not open in our system.
If you will not respond, then how can I know that you are getting or not? मुझे लगता है ऑनलाइन वाले तो है नहीं सर.
Sir, we are unable to open this file.
उन्हें बोलना अलाउ नहीं. रिकॉर्डिंग चल रही है ना. Dear participants, are you able to listen me?
Yes, sir. You are audible, but we are unable to open up this file.
So let's move further. Now we have data. Just this data. I will show you some CSV and Excel files. First, we are just discussing how to start with it. So we have data. Now these are some functions. Even the name of the functions are just like dictionary meaning. Length. What is the length of this vector? This one, 7. Sum. For addition of the numbers, just put the sum. For mean, just put the mean. Just for minimum, just put the min. For maximum, you can perform simultaneously. See, just max. What is the maximum value in this vector? Okay, what is the range here in the data? 2 and 15. What is the median here? Say 5. Correct. So all these things are here. Functions are available in R in such a way, in such a simple way. Just write the name of the function, and almost functions are available with their respective names. Quantile. You may or you may not be familiar with the word quantile. Summary. This is the most important thing. Summary. Minimum, first quartile, median, third quartile. Median is also second quantile, known as, and maximum. Even sort, find out the order, reverse sort, decreasing order. We will make user defined function for the mode. Next is some arithmetic. Here our x, data vector, log of x. Even by default base is exponential. log E. Usually we work when in statistics we have base E. So we want to change the base. We can easily change base equal to 10, base equal to 2. Now I want to add something in the vector. Just put the scalar. Even we can add two vectors like previously we have x1 plus x2. Okay, so respective addition will be here. If we want to add some scalar in the vector, we can put just scalar and plus. So it becomes the 1 plus x. Multiplication, just star function is available for the multiplication. So we can see, even we have x power function. This cap is specially used for the power, raised to the power 2, individual square of the element in the vector. Square root, say just square root, that is individual square root. Suppose y equal to x square. Okay, now y is this one, x is this one. Now find out the square root of the y. Then we will have same. Okay, these are some trigonometric functions. Some of some we already know the sum. Sine, cos, tan. Even sometimes when we are working distributions, not the distributions. Sometimes we are working on mathematical functions. So gamma and beta functions are available. I'm not talking. I'm talking. It becomes gamma n equal to. It becomes like n minus 1 factorial for the integer. Let's move further, or okay. So now just naming a vector. Now we have a vector x. This is the x. Now I want to put the names for these numerical numbers. Usually, what type of data we have? Let me show you one thing. Say just I have given this data set only to you. So like obviously we have some headings. Even we may have some row names. Let me show you another data. I will discuss this data set after some time. Say district, MPC, weight, and hectare size. I will discuss this data also with you. So we need some characters also for the data sets. So that's why we have the function naming a vector, and the function is just name. This is the, we have this x. Okay, now how many observations in this data set? How many observations are there in this data set? 7. 4. Length of x is 7. Okay, so for these 7 observations I want to put some names. So I have defined, say a. I need, if we are defining characters in any programming language, then we are to put those characters into the quotes. So just put the names in the quotes. Say a. Say b. And say last one m. So let's check, can we put these names? Yes, we can put. Even we can make matrix data frame directly here. But ultimately, I am telling all these things to you because just you are starting it. Otherwise, directly we work on CSV or Excel files. When we are in practice, when we learn this, we can easily work with data files directly. Another thing, how I want to extract only one observation or two observations from our data set. So we have this one. X is my data set and I need only second element. So we have second, just second column. I need second and fourth combined. I want to delete second column or second observation from my data set. Just put the minus. I want to delete first and third. Just deleted these. Correct? Let me show you all these things. This was our X, A, B, D, E, F, G, M. Okay. Second one, B. Second and fourth, B and E. And if you delete second one, then you have deleted B. So you have A, D, E. If you have deleted first and third, so first A and third D, the remaining. Correct? So in this way, these are very simple commands. These are very small and simple commands, and these are rememberable. Usually, what there is no need to yes, there is no need to like rote learning. So just if you are practicing, just if you want to find out the median, so just you can find out the median. You want to find out the mode, you can find out the mode. Just put the function mode. Obviously, mode is not available here, so we have to make the function of the mode here. If you want to find out the mean, then we can find out the mean. Now, this is the most important section, especially for applied sciences, especially for social sciences, economics, because we have data, a lot of data, and we have the popular form of the data collecting is the Excel file, MS Excel. So we can directly import and export data in Excel file. Let me show you one thing. Just see, this is cursor. You are seeing the cursor. This one here. Click on this one. Okay, you can directly import data. I'm just telling you the import. Text data may be in the text file. Data may be in text file. Data may be Excel. You have SPSS file. Your data may be in your SPSS. Your data may be SAS file. Your data may be in Stata file. Suppose I don't have at this time SPSS and Stata files. I have Excel file. Just browse. I have data sets. See. This is the Excel file, old version. Click on it. Type of the data, name of the data, number of rows you can define here if you required. But you require this library. Read Excel. Okay. But it is not advisable because it becomes difficult. It becomes especially difficult for the system to take directly Excel file. So it is advisable until unless you don't have time. It is advisable make each and every your data file into CSV. Okay, just you can import. Click. Now you have this data with the name of the MPC data. This one. If you type here, then you will have this data. Okay, you can work on it directly. So come to the point. Just come to the point. Importing and exporting. So we have these functions. I'm in this the whole slides. In these slides, I'm talking only the base R. Like that, I have not used in these slides read Excel. Why? Because read Excel is the extra library which you have to install in your R Studio or R. Okay, so I'm just talking about these basic terms. Read.table, there is a function. Read.csv, another function. It reads only CSV files. Read lines, instead importing data in lines. Source, reading in R code files. And the inverse is the dump if we want to export. Okay, just read.csv file has such type of command. Now let me show you. Let me show you this one. Okay, it is, I think, not available here. So just I want to import data, and for that we have a command read.csv. Just we have this read.csv. Okay, now data, you have to specify the location of the data, because I am working directly in this folder and my all data sets are available here in the data sets. Okay, and these are my data sets. So just put address of the file. Obviously address is available here, so we are to put address in quotes. Data sets. Inside the data sets we have file. Now you are to put the name of the file. Say data1.csv. data1.csv. You are to put extension also. I'm talking only CSV because I'm using the command read.csv. Okay, so I want to put it what variable we can put here? Name of the variable. File का नाम क्या रख लें यहाँ पर? चलो ऐसे करते हैं. My name is just. Let me show you what happened here. Let me show you what type of data we have imported. Such type of data. And what was the data here? This was the data here. Okay, but here you see NA not available. Let me show you the blank. Just see, it is blank here. Correct? Initially, I am putting here some observation, then I will show you what is the meaning of NA, say 16. This is the most important command here. Now I want to put header. I need header is true here. Another separator, because in the CSV file we put separator comma. See, just now we have another this data set. Now we can work on it. Same command can be used here. Read.table. Another command, read.table. CSV file. This one. So just a minute. First, let me show you. First, we should have data now. We have MS Excel. Just we put all our data sets here, column wise, row wise. One most important thing is that even SPSS, I don't know about much Stata and SAS and R. Data should be column wise. You remember if you are working on SPSS or any other software, then your data should be column wise, not the row wise. So in the R, you should have your data with column wise. If you have row wise, then you have to transport it, transpose it. So we have put it data, then we make a single file, because in the MS Excel we have sheets. In CSV data, we see that data is divided into rows and columns, but actually data is separated by commas. CSV, that is comma separated files. Let me show you this one. When we save the file, say for example, I want to save this file. This is the .xf. It came after 2007 Office, MS Office 2007. Before that, it was just Excel. Here we have a number of options available how we can save such type of files. So we save this file in this comma separated. This one, comma delimited. If we save this file, then we have extension. I have opened extension here, so we can show you the extension. This one, say book one. Extension is CSV. लोग open कर सकते हैं, देख सकते हैं ना extension. What is the extension here? That's why I have shown here like extension, file name extension with the help of this one. These are the options. Views, show the extension, display the full path. Files and folders, display file icon, folder path. With the help of here, you can just put the display hide, or you want to hide or don't hide, you can use this. Otherwise, like if you want to display, just click on it, file name extension. You have file name extension. So it is beneficial that what type of files we are dealing with. So comes to the command. Another command is read.table. Same command will work here. If you want to check out the help here, you can check out the help. Same command is work here. You can see this one, this one. Another command, let me show you another command also. That is important command. Read.csv. Let me show you. This is the most important command, which is very beneficial. When you run it, then we have a pop-up window and you can select any data file. Suppose I don't want to, I need data 2 or data 5, say, just click on it. Now check out this one. Again, we have to put here header equal to true. Again, we required separator. If you click on it, then you have pop-up window, then you can choose any data file. Obviously, it should be CSV. I'm talking only about CSV. Correct. Now I have data file. This one. This data I have here A, B, C, D, 4 columns. Each column has 5 observations. Each variable has 5 observations. There are 4 variables. Suppose I want to check out the structure. STR of this data set. You can see it is a data frame, 5 observation of 4 variables. And what are the variables? A, B, C, D. A is of integer type, B is integer, C is integer, D is integer. You can change it according to your requirement. Even these may be real numbers according to your requirement. I think before going further, if you have questions or queries. Is it too easy or too tough? Let me show you. Just a minute. Just a minute. You have put in your folder where you are working or where it is in the downloads. Just put in your folder where you are put that file, this RNB file. Where is this file? It is open. It is now in downloads. Your it is the name of beta one. Yeah. I have written this one because I have put this file in data sets with the name of the folder. Let me show you.
What I'm doing, I'm just quoting from.
Yeah. You can import in such a way, but because it is not the Excel, CSV file. No, it is CSV, no? Because it is not the Excel file. Extension is not this one. Nothing to do, just write this one. CSV. So Something is basically, this command is most important, especially for you when you have large data sets. So, do you want to try it or may I move further? It is very simple command, by the way. Just put the path here, the name of the variable in which you want to store your data. Read.csv is the command, a simple command, read.csv. So simple. Path between quotes and the name of the file. Whatever path, how we can choose the path. Suppose this is the path. Actual path is this one. If you are using Windows 7, Windows 10, Windows 11, you can find out the path. And this path don't work in any programming language. Not in the R, in any programming language. So you are to write, just to say, and I'm putting the another variable, read.csv, put the quotes, then the path, after that header equal to true, separator equal to comma. So just put one more backslash. Otherwise, you are to put this one forward slash. If you don't want to change, you don't want to do much work, just put one more backslash. And here the problem is that name, there should not be space between the names, because here CUH economics, we have space between CUH and economics. If I change the name, let me show you the another thing. Say I have the data5.csv, इसको डायरेक्टली यहाँ पे पुट कर लेते हैं data5 को बेसिक सार्स में. Now it will work fine. Oh, okay. Just it is not here. What will happen if the file is not here? Then you will have error. But if file is here, then what will happen? It will work like that. So simple. Otherwise, you can choose this command. This is my favorable command because with the help of this one, we can choose data anywhere from my computer. And the command is just how we can remember it. Read.csv. Even you can remove this one. Just choose dot files. Choose dot files. Left parenthesis, right parenthesis, and done. We required header, then we can put header true. We don't require, then we can skip it. We required separator, then we can put here separator comma. Let me show you just programmings. I'm not going detail into the programming. Especially in programmings, we make functions. You have seen function mean. We know that mean. What is the definition of the arithmetic mean? Definition of the arithmetic mean is just sum all observations and divide of the number of observations. So we can make our own function. For the sum, we have the sum function, and number of observation, length of the data. So divide by the length of the data. So we will have mean of the data. In such a way, we can make functions. And I made one function near the how we can write the function. Just write AR function. Say you can make any name. I have written here my dot function. So this is the main command function, and the argument, how many arguments you required, and the return, and then close it with curly braces. So I'm not going into the let me show you this one. This is simple most function. Just copy paste from here. By the way, it is there also. See. So I made a function square. There is no function square here. Obviously, we have, suppose if we have x, so we can put the power 2. Correct? Okay. So I want to make a function square. Just number. Argument is number. I want to square of the number. So answer will be the number into number like that, obviously, or you can just put the number raised to the power 2 here and the return answer. So we can make this function, select all these things, Control A and Control Enter. So now you have the function square. So write the function square. Square. Can we make square of x? No. Just. Yes. This one. So simply. So in such a way, we can go for complex functions also. This is the simple most example. Even when we required, especially for the simulation, then we required a lot of functions. We have to make a lot of functions. If your interest is not in the functions on the programming, so we can skip and we can go further. But let me show you just something. We can make function, and what is the error here? Like, because we have skipped right parenthesis, that's why error is here. If something we have missed, then we will get error symbol. These are errors. This is for standard deviation, length, etc. I'm just scrolling it. I will go for the next, especially next topic. How we can determine the sample size? We know about that the standard error. Okay. So we can make a function. Just I made a function samp.size. Argument is data. Here x is the data. N is the length of the data minus sum is dot na. We can check that is blank is available. There is any missing value. Na that is not available. None, that is not a number. NaN. Okay. So out we can find out this if there is any Na, then it will return that there is a Na. Now we can check it. Square root, it is for coefficient of the variation. I'm not going detail into the MLE. These are some difficult functions. I think you don't require these programming things in such a way. Let me show you some graphics. Skip all these things. Before graphics, it is important. Apply family of functions. In number of data sets available, and we want to do same thing for each and every data set. And suppose we have a function. Suppose we want to find out the mean. We have a data set which have 5 columns, and I want to find out mean for each column. So we are to find out the mean. How we can find out the mean? We are to put the mean and extract that particular column from the data set. But with the help of the apply family of functions, there are a number of apply family. There are a number of functions available in the apply family. So with the apply family of functions, we can find out or we can apply functions to each and every observation, each and every row, each and every column of the data set. So this is the important. So let me show you this one. Apply function. This is the first. Let me show you the what is the apply function. The function apply. This is the function. This is the syntax of the apply function. Apply data margin, and margin here is 1 and 2 only. It's purely depend on the. We assume that data is data frame in the form of the rows and columns, and fun is here function. Now comes on the this practice. Now first we make a data A1. We have such type of data set. Obviously data frame, we can simply use data one also. Let me introduce enter equal to read.csv and data is data 5. We have data 5 now. .csv, we put header equal to true, separator equal to comma, oh sorry, so we have A2 also. Now check out first. I'm choosing data set A1. Mean of rows, mean of first row. Let me show you A1. एक काम करते हैं, सबको फिनिश करते हैं यहाँ से. With the help of the Control L, it clears the screen. So check out first the A1. This is the dataset A1. Now I want to check out only first row. Can we find out the first row? How we can extract first row? This is the first row. Can I check out the first column? This is the first column. Now I want to find out the mean of the first row. A1, first row. Sorry, A1. We have this one. Okay, similarly we can find out the mean of the second row. This one, third row, this one. And suppose we want to find out the mean for each row. So we can find, if we put this command, then we will have mean for the whole data set, but not the row wise or the column wise. Suppose we want to say third column, so we will have this one. So therefore, with the help of the apply function, it saves our time. First, one show row wise, two show column wise. You will have this one. So easily we can use apply function. It is very easy. Even okay, our interest is to find out the standard deviation. So we can find out the standard deviation, median. Even we want to find out the summary for each column. Sorry, row. Here one is row. So we will have summary, such type of summary. Suppose apply this summary on the columns. So we will have this type of summary. In this way, we can find out easily. कोई दिक्कत नहीं. It's purely dependent. So let's move further and then we will come on the regression analysis.
Okay.
नीचे आ गया लेकिन नीचे आ रही है ठीक है I want to just show you some graphic features also. After that, we will discuss regression. I will take 5 more minutes here. This hypothetical data we have imported. Okay, and when we work on exploratory data analysis, then we will start like from the histogram. Just I want to check out the histogram. So just the command is here, hist, and we will have such type of histogram. Okay, histogram 408. Actually, our data do not suggest us histogram. Just a minute. So basically, we have A, B, C, D, 4 variables, and our data do not suggest here histogram. Just see bar plot. We have bar plots in such a way. What I put here, say I said that these are the score of or marks of the students. So you can write according to the heading, according to the requirement, what you required. Okay, just I want to change the color for especially only one, this one. Thank you. So these are some graphics features which are to be explored here. And even in this short window, we have these graphics. Whatever graphics we required, we can make here. Even we can like see the big picture. Even the most important feature is here the export, save as image, because sometimes we require to save our image into the PDF file, into the Word file, or we are making report. Then according to, if we are writing research paper according to the general requirement, we need some time off. So we have what type of features? We have PNG, JPG, TIF. These all types of files we can export. What is the size? What size should be here? We can make size. We can maintain aspect ratio. We can put the name of the file. Okay, so we have such type of features available. Next, explore some more things. Now I want to show this one, only this one. Usually we say that about the colors. These are the options available even for me, especially for me. Blue means blue, red means red. But you can better understand what these are colors. So these colors are available in R. What type of graphics you want to perform, you can make different colors. Just one more thing. Let me show you. Let's check what this color is here. So this is the color. Another thing is that how we can plot. If we have data, suppose we have two vectors data, then we can plot in such a way. Just a scatter diagram. If we have the relationship like that, we want to study the data. For example, we are considering here, yesterday I think sir was telling, Saul sir was telling that he has considered the data set for sale of printers. Yesterday he has discussed that data set now. So number of printers were there, number of stores were there, sale of the printers were there. Oh, it was there. Okay. So suppose we want to study the sale and the number price, sale and price. What is the impact of the price on sale a particular product? Then we can say that there is a relationship. So we need two data sets. For that purpose, we want to check out the relationship. So with the help of this scatter diagram, just see this scatter diagram. Even if you want to put color, you can put the color here. Say put the same color, COL. This color is here. Oh, it is not visible by the way. Say red. So we have such type of colors available. According to your requirement, you can put the colors. Even if you want to the grid, you can use the grid. Sorry. So you can put the grid here. Even we can go further for the plots, such type of plots with the help of only just put the type. What is the type here? Type equal to B, that is dots and these squares and dotted. Okay, if you put here L for line, so you will have such type of. Okay, even you can change the colors and the requirement. Even you can put the grids and the colors. So I'm skipping all these things because I have shown all these things in the PDF file you have with you. One more thing is that I want to show this demo for the pubs function. Just I want to show it. Sometimes we require 3D graphics. What type of the scenario is here? We can make such type of function with the help of such type of plots and graphics. Even we can change the colors here. Okay, and this is the wall corner data available in R. You can change the color, background, etc. We can remove the outer. Even we can change the direction also. Last thing is that only just one. There is another package function, not the package, wireframe. It is available in the latest package. Just I want to show you this one also. The same thing is here. Same data is available here. We can change according to the requirement. This data set is also available here. So I'm not discussing here because we have limited time. such type of scenario we can use. So just check out the next thing. We will discuss the regression. There is another PDF I have shared with you. Just check out that file. Give me 5 minutes only. Check out this file, and there are some data sets available here. Data sets are available here. For printers. That data set we have considered 20 stores. So it comes to new model of the printer. It is separate of the printer. It is separate 20 stores. Same printer sold and price of the printer. So check the relationship of sold printers and price of the printer. So now you are familiar with regression. I listened that sir have discussed a lot of things about the regression. I think there is no requirement to discuss all these basic things. I'm just coming to the my work. Actually, such type of relationship, that is, we have one dependent variable and some other independent variables, and how those independent variable have the relationship with the dependent variable. So we are to discuss that thing. When obviously we have only one independent variable, we say simple linear regression, and we have more than one independent variables, popularly known as exploratory variables. then that is called multiple linear regression model. So I'm not discussing these linear models. These even now you are aware with the columns of the autocorrelation, multicollinearity, heteroscedasticity. Yes, no? Okay. So I'm just coming directly to data set and the how to apply it. We have these 20 observations for two variables. Sold is here the number of printer sale by the store by 20 stores, and these are the price of that particular printer. So that's why the data is selling printers. And purpose is only here is that this is the purpose. What is the objective here? A company at the launch of the new model of printer wants to analyze sale at a number of stores to determine the best price, so that company can put the price of its product. Okay, variable, these are the variables. Store, name of the store. I have changed 1 to 3, like 20 store, 1 store, 2 store, 20. Sold, number of printers sold, and price of the printer. So first of all, we have to choose data. First of all, we are to model the data. Now my question is that number of printers are depend on the price of the printer or vice versa. This question is for you. Which one is dependent, which one is dependent, and why? Can anybody tell? Sale. Okay. So here sold means that we have a number of printers sold. So first we select the data. Just remove all these things. So if we are familiar with this command, because this is the basic command and easy command. Just a minute. So choose this command. Now we have the pop-up window, data sets, and selling of the printers. You can check it. Data are available. So we have data here. Now we want to make the model. Before make the model, just check out the scatter plot. How we can plot? Or first, before even plotting, we should know about something about the data. You will have length. This is the store, sold, and price. We have summary. Minimum is number of printers sold 100. First quartile maximum 160. Price minimum is 13,560 and maximum is 21,000. Price of the printer. Next we move about this. First we want to check out that what is the structure? Sorry. What the structure look like? If you see on the x-axis price and y-axis, on the y-axis sale. If you see, as the price increasing, sale is decreasing and almost linearly decreasing. So obviously we can see that simply this is nothing a mathematics or statistics. It is just, we can say, the interpretation. It is related. Obviously it is related, but negatively related. So we can find out the magnitude of that relationship with the help of the correlation. Even we can find out the covariance. I'm directly coming to the correlation. You can find out correlation between these two variables. You can see there is a strong correlation, minus 0.96, negatively correlated. As the price increase, sale is decreasing. So simple interpretation. Now comes out to the our purpose. There is a function LM. It is a very simple function. It is a really very simple function. What we are to do? Just put this command. LM is the command. Let me show you the LM command first. How it looks like. This have this type of code available, so we don't require such type of code. So come out to the output. First argument is the sale that is sold, and this symbol used as a separator, and this symbol is used especially in statistics for follows. So here what we say, y follows x. That means y depend on the x. So first argument is the dependent variable, second argument is the independent variable, and data, available data. We have seen this data already. This data is available here. And we store this output in the, I put a function name, variable name, linMD, sorry, for short form of the linear model. I have put it lin mode. And we have this one. This is the formula, and these are the coefficient, intercept, and the printer. If you see, the model is specified using the formula. This is the formula, so simple formula. Just dependent will follow the independent. If there are more variables, suppose price of the printer, sale depend on the advertisement cost. So you can put just if there is a third vector available with us, plus advertisement cost. So you will have, it becomes like multiple linear regression model. Now I want to check out what is the class of the linear model function, LM function. This is just class LM, and what are the names? These are the names. These values are available with it. I will discuss each and every what is the coefficient with this one. Just put it, say coefficient here, lin mode, and put this dollar and say coefficients. These are the coefficient, intercept, and price. This is the slope parameter. All of you are aware with the regression models, no? Basic regression models. Okay. And this is the intercept. One more thing. Before going further, first we should check that assumptions are fulfilled or not. If assumptions are not fulfilled, then you will not have good fitted model. And if you don't have good fitted model, then your forecasting or the prediction will not have the good. So we will discuss diagnostic each and every point for the each and every point. Next one thing, let me show the residual. Just and then we will go. These are the residuals from these models. And we know that mean of the residuals should be 0. This is the first assumption. So can we check it? Yes, we can check it. So mean of the residual, if you see 4.38 into 10 raised to the power minus 16, even if you put round here after the decimal, 5 places, then you will have 0. Even 10 places, because it after 16 places, so it is almost 0. You can check it. Even we have we can check it that we have what type of residuals, what is the distribution of the residual. We will discuss each and every of them. So what we see, these 12 names are available. These 12 values can be extracted from the LM function. Coefficients, residual, effects, rank of the explanatory variable, rank of the explanatory matrix. Basically, if you have the general linear model y equal to x beta plus epsilon, then rank of x. If rank of x is less than the number of unknowns, number of parameters, then the problem of the multicollinearity occurs. वो बोलते हैं ना that one of at least one of explanatory variable have the linear relationship with other. If that linear relationship occurs with explanatory variables or within explanatory variables, then the problem of the multicollinearity occurs. So we can check rank here. If rank is the number of the unknowns, then we can easily find. Okay, so X level model, what is the model here? What is the fitted values? What is the degree of freedom for the residual? We can check each and everything. Even we have discussed here. These are the values. Oh, no. These are the output values. Even after that, this only LM function gives you a, LM function is a versatile function available in the R, basic R. What we can do with this function, if you print, you can summary, you can find out the summary, you can find out the coefficient, residuals, fitted values, even analysis of variance table, prediction, plots, confidence of interval, even predictive intervals, even residual sum of squares, variance covariance matrix. It comes out variance covariance matrix with the help of the variance covariance matrix. Even we have checked that it comes out like sigma square x transpose x inverse. You can find out that value. Log likelihood function with the assumption that errors are following normal distribution, normal 0 sigma square or normal 0 1. It's depend on the value of the sigma square, that is standard deviation, that is sigma is the standard deviation here. Even if you want to compare two models, so you have AIC, Ekak Information Criterion. So what we do usually, we fit a number of models and find out which one is the best model according to our data set. So you can find out the information also. See, only this LM function, with the help of only this LM function, you can do lot of things. Now see one by one. Check out this one. This one, summary. From the summary, what we get? We get from summary Summary of the residuals: minimum, first quartile, median, third quartile, maximum, and the coefficient estimate. In mathematical notations, we say beta 0 cap, beta 1 cap. Standard error for beta 0, t value using t-test, and the p values. And these two p values suggest that all like beta 0 as well as beta 1 should be available in the should remain in the model. Even we will have r square, adjusted r square. Even these two values suggest us that our model is very good fitted. Obviously, it is very high value. That is 92, around 93% variation is explained by our model. Now, another thing is that let me first show this thing and then we'll discuss it. We can plot. By the way, we know the plot function, and plot function can be used using the formula like sold into price, data is printer. I have changed the color, point type, and the width. F-line is the F-line from my linear model. So let me show you this figure. Blue dots are the data sets, scatter diagram, and F-line, this red line is just fitted line from the model. And this shows that, oh, it's very good fitted because it is all data are surrounding our fitted line. That's why we can consider our model is good fitted again. But visualization give us just rough idea, so we should have some concrete numerical values. Now comes out to the point. See, just interpretation. What we have: intercept, fitted values, this one, standard error, this one. I can say that this is the high standard error. But when the intercept is this much, so it is not so high. Okay, and the estimated slope is this one, and with this is the standard error. All these things are available here, like also t statistics, p values corresponding the individual test of the hypothesis. Okay, both p values are very low. That's why we can say our test, if we are considering, if we are testing, so if we are considering the null hypothesis, चलो ऐसे डिस्कस करते हैं इसी पे ठीक है नहीं मैं ऐसे बता suppose our null hypothesis is that beta 0, that means beta not equal to 0. That is what is the role of the role of the intercept in our model is significant. So here null hypothesis is straightforwardly rejected. Okay, our test is significant, so intercept should be there in our model. Another, if you see output, check out the output. These are the outputs. See, beta 1, estimate of the beta 1 cap, OLSE. All of you are aware with the ordinary least square estimation method, no? Okay, so OLSE of beta 1 comes out to this, and what is the p value here, and what is the null hypothesis here? Null hypothesis is that h naught such that beta 1 equal to 0. That means that explanatory variable should be in the model or not. Again, this null hypothesis is straightforwardly rejected. That this intercept should be, sorry, not intercept, this slope and the explanatory variable should remain in the model. So that's why our model is good fit. Let's go further. I have plotted this one. So with the help of the even visualization, we see that our model is good fitted. Even we can find out the prediction. All of you are aware with the prediction, no? Okay, so just if we want to predict Let me show you one thing. We have data X, no. So I want to put a data. All of you have data or sale of the, no, price of the printer, because sale of the printer depends on the price of the printer. Now I want to predict or future forecasting for the different prices. Can you tell me some prices? For prediction purpose. You have data now, selling printer data. So you can see price of the printer. Can you suggest me some? I want to check out that what price I should put for my product or my model, then sales should be high. Can you suggest me some prices? अरे अभी तो कल का दिन भी बाकी है, अभी इतने उदास क्यों हो रहे हो? थक गए मैम ये सब लोग. अरे कुछ तो बता दो. कोई ऐसे कह देते हैं 5,000 रुपए में प्रिंटर मिल जाए बाजार में, तो इससे क्या अच्छी बात है? 16. Some other? Say for example इतना ही करते हैं. Let me show the, sorry. This is the help of the predict function. First one, the object. We have the object, lin mod, new data. Okay, and we want to find out the standard error or not. Sometimes we required it, sometimes we don't require it. So we have our model, LIN mod, new data is X. Okay, X should be data frame. So data frame डाल लेते हैं. हमें क्या करना है? WRIT write dot table X file equal to data X dot CSV. Separator equal to चेक करते हैं कोई डेटा फाइल आई है हमारे पास. ये आ गई डेटा एक्स. Okay, so predict data equal to, just a minute, X equal to read.csv file equal to choose dot recall कर लेते हैं data. So now we will have X. एक heading भी डाल लेते हैं. Header equal to true. Now we will have this one. Now predict. Two row variables for those 120. Just a minute. Let me show you just something is you see here. Let me show you the next example. I will show you the prediction here. Don't worry about it. So I considered this example only for showing the how we can predict how we can find out the coefficient and how we can find out the we can study the hypothesis, null hypothesis that our intercept and predictors or coefficients are equal to 0 or not. Another example I have considered here, study of the driver license data. So let me show you this data set. Only the years and license drivers. Here year start from 1962 to 2011. And how many licenses are given to drivers in a particular office. Okay. So just year, it is time series data, year and the license given to the drivers. So I have considered here just as usual, we have data, LIC drivers. So this is the structure data frame of 52 observations with two variables, year and license. Next, we consider L model, that is LM function. Here driver, and here what we are considering here, license are depending on the years. In which year, how many licenses are given to drivers. So just see, this type of model comes out finally. This is the intercept, this is the slope and the year. Year, as you change the year, even in the prediction, we will do a prediction for this one. As the year change, then the license, number of license are changed. So what we do, first we do check out the relationship with the help of the plot and then fitted value. You can see, just see the green line, green dots. You can see in the 1960, very low number of licenses were given. Even 1970, number of licenses are increased. 80s, 90s, 2000 and 2010. So it is again linear relationship, and even if we fit the model, and it is very good fitted model. I have skipped the first step. only the scatter diagram. I have not considered the scatter diagram. Directly I am showing you the scatter diagram and the F-line, that is F-line from the fitted model. Now the summary. Check out, this is the intercept, standard error. Again, this is the p-value. That means intercept is required here. And the p-value for the year, again it is required. Obviously, what we consider the null hypothesis that H0 such that beta 1 equal to 0, which is straightforwardly rejected, even at 1% level of significance, even at 0.1% level of significance, because it is very, very low value, almost 0. So whatever null hypothesis, whatever level of significance you put here, it will be rejected. And the model, how good our model is? R square 0.99, even adjusted R square 0.99. So model is almost good fitted, almost good fitted. Not the good fitted, even best fitted. So these are some comments here. There is a positive association, obviously. It is showing like as the time increasing, number of license increasing. If you see, now go to the estimated coefficient where there is one row for each of the term included. We can estimate. We have estimate, standard error, t-value, even p-values, multiple R square, residual, even p-value for the f-test as well as t-test. Both p-values suggest that our model is good fitted, and both we are to consider as intercept as well as slope also we have to consider. Next, I am coming to these points, coefficient and residuals. Let me see the coefficient. This is the beta 0 cap, OLSE of intercept, OLSE of slope. These are the OLSEs. Residuals, these are the residuals. Even we can check these residuals. Okay. So when we fit the linear model, then we have to check that our linear model, we have considered the what model we have considered or what data we have considered, that all assumptions are fulfilled or not. The first assumption is that mean should be 0. When we have data in real life, so our assumption is that data is normally distributed, and errors are normally distributed. If errors are normally distributed, then our response variable also will be normally distributed. Like that, epsilon follows the normal 0 sigma square. In that case, y will follow x beta sigma square. So check out stream plot. Stream plot suggests that it is like see -6, -4 to -2, 0, 2, 0, and it is just symmetric. Let me show you this one. So first thing is that it is, if it is symmetric, then it may be normal, but say that it is normal or not. What we are saying, it is just symmetric. Oh, okay, I have just a minute. अभी data तो लिया ही नहीं. This is data, structure of the data, the linear model. This is the stream plot. You can see this one. It suggests that our distribution of the residuals is symmetric. Agree till here? But now we want to check something different. That really these assumptions are fulfilled. So we have to diagnose our model with the help of the plottings. So plot function gives us this facility. And let me show you the first the plots. These are the plots. Residual versus fitted values and the residuals. Normal QQ plot, scaled location, standardized residual plots, residual versus leverage plots. Even Cook distance also we have. Now, finally, we have this function. Only the single function, lm function, give us each and everything what is required for fitting of a linear model. It may be multiple linear regression model, it may be simple linear regression model. So with the help of the first plots of the residuals against fitted values in normal QQ plot. So first one tell us that that the first assumption, expected value of epsilon, that is mean of the epsilon, is 0 or not. Second plot suggests us that residuals follow the normal distribution or not. Okay, so let's check. I will show these all things. Even we want to check one by one. So just put the command. Let me show you the command. Let me show the command. This one. Enter one. First plot. Enter second time. Second plot. Third plot. Fourth plot. If we need individual plot, so we are to use which plot. So put here just which one. First one. If we put here 2, we have second one. If you put here 3, then we have third one. If you put here 4, then we have 4 1. Cook's distance. If you have studied the econometrics or the regression analysis, Deepak distance is available in the literature for finding the diagnostic of the our model is good fitted or not. Fifth one. Is there 6th one? Is the 6th
Sir,
one?
your screen is not visible.
Distance versus leverages. So let us discuss one by one.
Sir, your
this
screen
particular
is
model.
not visible.
So this one, the residual versus fitted. What it says, the dotted line at the residual is equal to 0. Indicate our fit line. See, this one, 0 line. Any point of the fit line obviously has 0 residual. So this do not suggest. Oh, one more thing. Let me show you residuals. The model is ln model and the residuals. These are the residuals and what is the mean. We can, by the way, these are the sample values. That's why it may or may not be equal to 0. If you see, it is almost 0. Almost 0. That is 6 minus 6.4 into 10 raised to the power minus 17. Like 16 0, then you have numerical value. Okay. See, for our, especially this point, we can see that our residual have a curve pattern. What we have shown by the red line, this one. The fitted line does not describe how the response behaves when the input changes, since the relationship is non-linear. Ideally, what should it be? Ideally, it should be around this. These dots, all these data should be around this one, this line. That is called good fitted. Even our model says that R square says that 90% model is good fitted. No, sorry, 99%. That is 99% variation is explained by our model. But this assumption is not fulfilled here. This could mean that we may get a better result if we try a model with a quadratic term. So it is not exactly the linear model, or especially the residuals. Next one, go for the normal QQ. It says that normality is available. Almost all data are available this line, around the line. So it can be noted that the residual do not follow the straight line, but it is almost around this line. So we can consider approximate normality is available. Next, see this one, scale location plots. Spread of the points across the predicted values. Basically, it's tell us about the variability. Okay. Again, It can be noted residuals are not equally distributed. So that means there may be heteroscedasticity also here. So I'm not another thing that Cook distance is the good measure of the influence of the observations. So let's see about the Cook distance. It is not given here. This is the Cook distance. Okay, even our model is very good fitted, but when you check, when you use the diagnostic tools, then this is the problem that even our model is good fitted. What we see that in statistics we say model is good fitted, but prediction is not correct, because we usually don't follow the assumptions. Until unless our assumptions are not fulfilled, our prediction will not be. Even our assumptions are not fulfilled, then what will happen? Our results are coming good, like 99% variation is explained by our model. Okay, even null hypothesis, both null hypotheses are rejected, but prediction is wrong, because there may be a violation of the normality of the data, there may be violation of homoscedasticity, there may be violation of multicollinearity, that is the rank of X is not equal to the number of parameters or unknowns. So this is the main problem. These are some points. Even we have some outliers also. Even this is the suggestion. If you see the point number, this one 51 and 52, these are the outliers. Even 5. I think I should stop here. Now, if you have questions, so discuss with me. I think so. थक गए मुझे लग रहा है मैम, 4 दिन हो गए ना उन्हें झेलते झेलते. Actually, if you just start the R, I cannot comment on this data, but if you start the R and even you are from economics and you encounter with econometrics, obviously you have economic data, it may be panel data, it may be cross-sectional data, it may be time series data. This LM function give you each and everything. इस LM function के बाद आपको कुछ नहीं चाहिए. Just you should know what we can do with this LM function. मेरा पर्पस सिर्फ इतना था. Let me show you the just I want to scroll these slides. Obviously, we have such type of structure. We have number of more parameters, number of more predictors. In this, I have considered this data set. Let me show you the cement data. So what we are saying here, there are 4 integrants for making cement and the heat for making cement. And what happened here? This is the cement data. If we fit the model, see, this is cement data. This is the structure. 13 observations of 5 variables. Integrand 1, 2, 3, 4. So we have considered like what I did here, I did it like manually. Fifth, that is what I say, that heat is depend on the integrants. Heat is depend on the integrants, and finally comes out this model, y equal to this one, this one. This is the manual way, by the way. Even you can use lm function, and there is no need to to do these things. This is only for residuals. You see, this is the line. Around this should be the all data should be available. That is, residual should be available for checking the first one. So I think I should stop here. मैं भी समझ गया सब.